Hello guys, good evening. Today we are going to have a electrical session. So the session will be like this. I am having a sorts of questions. First I will be asking question, then we will anyone who is knowing about that question, he will be delivering his concept, and then we'll discuss if any doubts or anything. Okay. So let's get started. So the first question is, what is alternator? Kiran, you remember what is alternator? Hmm. Kiran, your voice.
Hello.
Huh. Now.
So basically, alternator is a device
Hmm.
which converts the mechanical energy into the electrical energy.
Hmm.
It works on the principle of Faraday's law of electromagnetic
Hmm.
induction that states that whenever a changing magnetic field is associated or linked with a conductor, an EMF is induced in that conductor.
Hmm.
And when a conductor forms a closed coil, the induced EMF induced current flow through that coil.
Hmm.
So basically, alternator generally used in automobile sector or automobiles in order to generate electricity. So
Hmm.
basically, the alternator is made up of the two devices mostly, that is the stator and rotor. So
Hmm.
stator is the stationary part and rotor is the rotating part. So on there are two types of windings basically used in alternator. That is the armature winding and second one is the field winding. So on the stator there is a armature winding is wounded over there, and on a rotor there is a field winding is wounded on there. So when we use the small amount of the DC supply to that field winding which is wounded on the rotor, so it get excited and the magnetic field is induced, but still the EMF is not induced in that conductor, because for the generation of current we require the changing magnetic field. So basically changing magnetic field is created by means of the rotating the rotor by means of mechanical energy from the engine shaft. So when we rotate the rotor by means of the mechanical energy from the engine shaft, the changing magnetic field is created. So because of that, the current is induced in that stator, and we get the current in a form of AC. So we have to convert it into the form of DC for the storage purpose inside the battery. So we added one device like the rectifier. So rectifier converts the AC current into the DC current, and this DC current is stored inside the battery.
It's a too long, yeah. I am fearing that interviewer get bored. Okay. So I have prepared it like anyone other, but Kiran, you have mentioned all the concept. You didn't left any. You also mentioned that there is a yeah, diode that converts AC into DC.
Rectifier.
Rectifier, that is diode only, na?
Hmm.
Diode rectifier assembly. So anyone else like to answer? So the first point will be like you have spoken about that it converts mechanical energy into electrical energy. The second was that it works on the principle of electromagnetic induction. The third was the construction, like it has rotor, it has stator, it has diode, the rectifier, diode rectifier, and then fourth, that how it works, like
So don't say diode. So basically, it is the series of diode connected with each other. So that's called as a device rectifier. Most probably the word rectifier.
I have just memorized the word diode rectifier assembly in the system. Okay. So like what I have done for memorizing it, like everybody got to understand what actually alternator is.
Yes, Gyan.
Uh,
One more point I think that we should mention.
like what?
Kiran mentioned that we
Mm.
will be converting the mechanical energy into electrical energy.
Mm-hmm.
But the point to note is this electrical energy I'm not using directly in the car.
Yes.
I'm charging the battery. It is not that all the dashboard, whatever looking, your indicators are not running on your alternator. I'm only
That
charging the battery which is being used. So this is maybe an important clarification, because on ship the generator is directly powering everything up. There's no battery on ship. But in a car, the alternator is only charging the battery, and the battery is supplying to everywhere wherever it is needed. So maybe this point.
so for to conquer this concept, we can say that like the alternator is an electrical generator that produces AC current, alternating current, by converting the mechanical energy into electrical energy. Then
So
we will.
why generator? You added some extra word. So interviewer maybe ask what is generator. So why are you facing that extra question? Na? So just say the stick on the word alternator. Don't give any kind of word which is give the
Yeah,
extra
so
question.
as Kiran mentions, don't give an additional keyword. You can word it slightly in a smart way to dodge a question on generator by saying the alternative will produce. So
Mm,
instead of saying generating, generator, all of that, you can just say produce
mm,
and then proceed with that. So on produce, he'll not question you on generator. That will
mm,
not cross his mind at that point of time. So maybe
correct.
with some word play, you can try to avoid some
So
unwanted cross questions.
I will try that, but for the backup, I have just underlined the word generator and made a start that I should also know about this generator concept. But what is generator? Alternator is also generator that generates alternating current. Okay. So I was saying that I have to still memorize the word by word, but the concept needs to be clear in this meeting. Okay. So the first was it converts mechanical energy into electrical energy in the form of alternating current. Okay. The second is that it works on the principle of Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction is what? There is two law of Faraday. Yeah, I glitch, I lag. Don't know why. It's my like I'm not a person who stammers, but whenever I speaks, like I have developed this habit. Anyway, I'm trying this. So Faraday's, there is two law from Faraday. The first law is state that when there is a relative motion between electric circuits and magnetic field, then there will be the induction of EMF. And second law quantifies the amount of EMF will produce will be equal to the amount of flux that is linked with the conductor coil. So these are two Faraday's laws which should know, that is the working principle of alternator. And the third, the construction of alternator. It has basically three parts, that is stator, rotor, and diode rectifier assembly. Stator, rotor, as the rotor rotates, it induces current in the stator windings, and further that current will be AC current, and that will be converted into DC using diode rectifier assembly, and then later it is used to charge battery or powering the electric vehicle electric powering the vehicle, the automobile where it is used. Basically it is used in automobiles mostly. So I have covered all the concept behind alternator. I have left anything. Yeah, jackpot is
We can also include exciter, right?
what?
Exciter. Stator,
Yeah,
rotor, exciter.
see, we are mechanical engineer, na. Kiran has very deep knowledge. Kiran still explained the how this rotates and all. We are like the that the how that much concept we should know, and can like interviewer feel that he knows that we should not go in that including exciter and all, because the
Oh,
purpose
sorry,
is
guys. Sorry.
it's okay. We'll be discussing later everything, but after our interview. Okay. Okay, so it is, we are done with the alternator. Anything, any doubt? Yes, the one doubt is that where the electricity where is the current is generating in the alternator. Anyone, guys? Subham, you know? Subham Jaiswal.
No, bro.
In alternator, where current is being generated? Okay, let me ask Pradyum.
In the stator winding.
Yeah, correct. Stator winding. So this thing we should remember, that when the rotor rotates, it induces electric current in the stator winding. Yeah, the principle is electromagnetic induction. So, okay. I want to ask one thing, Avito, Kiran. Should I also read proper wording with the proper wording, like for the people who will be seeing later this recording? That is a that I have written in a structure way, a structural
Okay,
way.
sure. Maybe that will help them,
Oh yes,
just
sir.
get one proper
Oh,
consolidated answer.
yes, consolidated is the word of my. Is consolidated means
So consolidated
you lost your voice.
answer, you're putting all of that into one place.
Mm.
So we'll just be taking small segments
Oh,
of the
mm.
total answer and compiling it, or just
Yeah,
grabbing it all into one area.
compiling. Okay, all right.
Whatever, yeah.
Yeah. So alternator is an electrical generator. Alternator is an electrical device. We can also say that converts mechanical energy into electrical energy in the form of alternating current. The alternator consists of rotor, stator and diode rectifier assembly. The rotor is connected to the engine crankshaft and rotates within the stator, which is a stationary set of wire windings. As rotor spins, it creates a changing magnetic field that induces an alternating current in the stator winding. The alternating current is then converted into direct current using the diode rectifier assembly. The electrical output from the alternators powers the vehicle electrical system and recharges the battery. It is commonly used in automobiles to generate electricity and charge the battery while the engine is running. I missed that point, that it is connected with the belt of crankshaft. Kiran told about that also. So is it was understandable?
Yes, Gyan, it was
So
understandable.
moving on with the next question. Yes, someone has unmuted.
So, can you explain the diode rectifier function, bro?
Just remember this diode rectifier is to convert AC current into DC current.
Okay.
Okay, all right. Huh. Now the second question is, what is generator and working principle of generator? The first is the first point for every electrical device is that the generator that converts mechanical energy into electrical energy, motor that converts electrical into mechanical energy, will be the first point that we should stick with every answer, na, for electrical, like generator and motor and all. So anyone like to explain about it, what is generator? Something, anything, right, wrong, no problem, try. Yeah, actually I remember, I have tried to memorize it and now I am feeling I have also forgotten. Okay, let me Kiran, I will be, are you there, Evito? You people will be
Yes, yes,
listen.
yes.
Let me try it, not from the my memory only. Okay, that a generator is an electrical, is an a generator is a device that converts mechanical energy into electrical energy. Uh, it cons uh, it consists of turbine that rotates the rotor, turbine or any engine that rotates the rotor. Okay, so the working principle of generator is also electromagnetic induction, and in the generator the current is induced in the rotor rather than stator winding. Short and the construction is the same as alternating current, alternator, that is stator and rotator. And in rotator Yeah, what is the structural difference between alternator and generator in machine?
Generator can generate both AC and DC. Alternator can generate only AC.
No, 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 no.
Mm,
So basically, there are two types of generator. First one is the AC generator, and second one is the DC generator. So basically, AC generator coupled with the split ring works as a DC generator. Also, that device called as the commutator. AC generator connected with the commutator acts as a DC generator. And talking about the alternator, so basically, alternator is a different part. Basically, it is used for only for that automobile sector, because we know that the automobile sector, that is the automobile is continuously running in condition. So if we uses that armature and that slip ring brushes, so basically because of the continuous contact with the brushes and that, we require the higher maintenance over there. So to avoid that, we just create the electromagnet to basically reduces that part of the. Hello, I'm audible.
yes, yes, you're audible.
So to reduces that maintenance part over there.
All right. So, like, interviewer will not go in that much deep now. You have gone like the AC generator, DC generator, one uses commutator, one is uses split ring. Like,
So I just simply says about the difference between the alternator and generator.
okay. All right. So the basic points is that in generator, the first point is in generator it is really needed to say that it consists of an engine or turbine that
Yeah.
drives a rotor within a stator.
Excuse me, Gyan,
Yeah.
Sorry for the interruption. Actually, it is not audible. Can Sadhana Kumar can he mute?
Okay. All
Yeah,
right.
thank you, thank you.
Okay.
Yeah, Gyan, please repeat.
Yeah. So in a case of generator, my question is to Kiran and Avito. It is really required to mention that to say like a generator is a device that convert mechanical energy into electrical energy, but it consists of an engine or turbine that drives a rotor within a stator. It is really required to say that it consists of an engine or turbine that drives a rotor within a stator.
It's depend upon you. It's depend upon you. So basically, if you says that, it's okay, and if you not says that, still it's okay. So basically, our aim is to giving the just mechanical energy. So
Hmm.
we can giving it by the engine, by giving the hand
Hmm.
manual. That's
Hmm.
not a big problem.
Hmm. And in
Yeah, I think basically the goal is to express that it will run with the input of rotational mechanical
okay,
energy.
Yes, yes,
so
yes.
okay,
So
That's
you
it.
want, you can specify how that is, in which case, whether
okay.
it is, engine or whatever.
Uh, in a case of generator, electrical current induces in the, who is going to tell other than these guys? Uh, Subham, Rakesh, anyone?
Again, just repeat the question. What is it?
The In a case of generator where electrical current is induced in stator, in rotor, in stator winding or in
Okay.
rotor winding.
In stator binding, I think so.
Anyone
Is it?
else?
In
Mm,
rotor winding.
in rotor winding. Remember this, in a case of alternator, the current is induced in the stator winding, and in case of generator, the current is induced in the rotor winding. Okay. Um,
Okay, again.
yeah,
Okay, again.
uh, that you told me only
Gyan,
in earlier.
can you repeat?
Yes. I am repeating the question, the structural question which I have made. Okay, I have to memorize it one word to word, but let me read it for you. A generator is a device that converts mechanical energy into electrical energy. It consists of an engine or turbine that drives the rotor within a stator. The rotor contain wire windings, while the stator has a magnetic field. The working principle of generator is electromagnetic induction. As the rotor spins within the magnetic field, it creates a changing magnetic flux, and this changing magnetic flux field induce an electric current in the wire winding of the rotor through electromagnetic induction. The generated current then can be used to power electrical devices or started later for providing electricity in various applications, and are stored for later use, providing electricity in various applications. Clear, guys? Any line you didn't understand, please let me know, we can discuss. Like you got to know na, as the rotor spin within the magnetic field is in stator winding, and it creates the changing magnetic flux. You know, the when there is a relative velocity, relative motion between magnetic field and the conductor, there will be a change in flux, magnetic flux, and that will induce electromagnetic force, that is current. I said it right or wrong, Kiran?
Can you repeat?
I just told that as the rotor rotates, spin within the magnetic field, that is magnetic field is in stator winding, it creates a changing magnetic flux, and I said that the magnetic flux that will induce current EMF because of the relative motion
In
between the
generator? In generator?
generator. Yeah.
Okay. Okay.
No, I will be sharing the notes also, and also tell me that I have written it okay now. If I will speak this answer in the front of interviewer, then it will be like short and concise, and also contains the proper thing which needed. You have just heard this generator uh, concept. It was it okay?
थोड़ा और एक्सप्लेन किया तो अच्छा होगा। मतलब परमानेंट मैग्नेट होते हैं, जब मैकेनिकल से मूव करते हैं तब मतलब जब वो रोटर को रोटेट करते हैं तो मैग्नेटिक फ्लक्स चेंज होते हैं, उसकी वजह से ईएमएफ इंड्यूस होता है। सो इंड्यूस्ड ईएमएफ, सो जो कंडक्टर है वो क्लोज कॉइल रहता है, इसकी वजह जो इंड्यूस्ड करंट है वो फ्लो करता है। सिंपल, उसमें स्प्लिट रिंग होते हैं, स्लिप रिंग होते हैं, ब्रशेस होते हैं।
इतना
मतलब
ज्यादा तो
कंस्ट्रक्शन के
इलेक्ट्रिकल
जितने
इंजीनियर को भी नहीं आता होगा, लाइक थोड़ा मोड़ा।
नहीं रे,
तू पता है क्या कर रहा है कि
सिंपल मतलब
तू
पार्ट्स तो
इंजीनियरिंग कर
एक्सप्लेन
दे
करने
रहा है
पड़ेंगे ना।
उसमें कि होता कैसे है, कौन सा कैसे घूमता है ये वो। प्रिंसिपल बता दो क्या क्या
अरे
पढ़।
क्रॉस क्वेश्चन से अच्छा है ना। मतलब
हाँ
इतना भी नहीं कि 1 मिनट में हो जाएगा। 1 मिनट में अगर तू दम दम से
चल।
बोलेगा ना तो
हाँ,
भी हो
अरे
जाएगा एक
क्रॉस क्वेश्चन
मिनट
से
में।
याद आया, ब्रजंगा सर में तो चल जाएगा ये। मेरे को जैसे प्रिंस सर ने पूछा था कुछ क्वेश्चन, ही हैड आस्क्ड टू मी, एंड आई स्टार्टेड लाइक एवरीथिंग. He said, I just argue it was like a monotonous for me, being a boring session. You are not here to show
हम्म।
off your knowledge. Just tell me up to the mark. If there is cross question, then you go into the deep. Okay.
हाँ,
Then, and I know that how it is. I know barely that how because of permanent magnet and uh, this is all the things behind that for split ring commutator and all the workings of that.
भाई
uh,
पार्ट्स तो एक्सप्लेन तो करने पड़ेंगे ना, पार्ट्स तो एक्सप्लेन करने पड़ेंगे ना,
तो
पार्ट्स तो मेन है ना।
हाँ, तो ऐसा करूंगा कि एक और नोट्स
मतलब क्या
बनाऊंगा.
सिंपल सिंपल क्या बताना है, मतलब पता है क्या? अल्टरनेटर और जनरेटर में कभी भी क्वेश्चन आया तो क्या बताना है
हम्म,
कि किस पे कौन सी वाइंडिंग होती है। ये अगर इंटरव्यू को पता चल गया
हम्म,
तो समझा नहीं, पार लग गई किस में कौन सी वाइंडिंग होती है। जैसे कि अल्टरनेटर के
हम्म,
स्टेटर में उसका आर्मेचर वाइंडिंग होती है और रोटर पर फील्ड वाइंडिंग होती है। उसका अपोजिट सेम इधर जनरेटर में।
अच्छा.
तो जनरेटर में वाइंडिंग ही नहीं होती है परमानेंट मैग्नेट की वजह से, आर्मेचर रोटर पे कनेक्ट होती
हम्म, गॉट इट यार। तूने अपने तरीके से इसको एक्सप्लेन नहीं ना किया। यू हैवंट एक्सप्लेन इन योर वर्ड्स, जस्ट यू हैव एक्सप्लेन्ड अल्टरनेटर और यू हैव एक्सप्लेन्ड दिस जनरेटर।
जनरेटर तो नहीं किया मैंने।
प्लीज एक्सप्लेन ना, द रिकॉर्डिंग विल हेल्प।
हिंदी में कर दो, अच्छा
कर
होगा।
दे कर दे, बहुत दिन
तो
से
बेसिकली
फ्लुएंसी
कैसा
खत्म
होता
हो
है,
गया। ठीक है
ठीक है तो
होगा।
हेलो।
हाँ हाँ, कैरी ऑन।
सो बेसिकली जनरेटर में कैसा होता है कि एक तो परमानेंट मैग्नेट होते हैं दो, नॉर्थ एंड साउथ पोल। सो वी नो दैट द मैग्नेटिक लाइन ऑलवेज ट्रेवल फ्रॉम नॉर्थ टू साउथ। सो जो मैग्नेटिक लाइंस होती है, जब हम वो और जो रोटर होता है उसके बीच में रखा होता है, नॉर्थ एंड साउथ पोल के मैग्नेट के बीच में। तो जब भी हम रोटर को घुमाते हुए तो उसकी वो सरफेस चेंज होता है। सरफेस सरफेस की वजह से मैग्नेटिक लाइन फ्लक्स जो होती है वो कट होती है। उसकी वजह से ईएमएफ इंड्यूस होता है। ये कौन बताता है? वो लॉ बताता है, इलेक्ट्रोमैग्नेटिक इंडक्शन का लॉ, फैराडेज का। सो इसके हिसाब से क्या होगा, जो हमारा करंट है वो वो मतलब वो क्लोज्ड कॉइल में आर्मेचर में फ्लो होना स्टार्ट होगा। पर आर्मेचर के दोनों एंड में हमने वो क्लोज सर्किट कर दिया है। और एक एंड पे मतलब ब्रशेस एंड स्लिप रिंग लगाई होती है। मतलब वन एंड ऑफ दैट आर्मेचर इज कनेक्टेड टू द स्लिप रिंग विद द हेल्प ऑफ ब्रश। जो स्लिप रिंग है वो आर्मेचर के साथ घूमती है, बट आर्मेचर एंड ब्रश के बीच में डायरेक्ट कांटेक्ट नहीं होता है। कांटेक्ट होता है पर वो पार्ट दोनों मूविंग होते हैं अलग अलग। मतलब जब वो आर्मेचर घूमता है सिर्फ खाली उसके साथ स्लिप रिंग ही घूमती है, ब्रश नहीं घूमता उसके साथ। ब्रश सिर्फ कांटेक्ट में होता है, कॉन्केव कांटेक्ट में। सो सो जब भी वो फ्लक्स चेंज होता है, करंट क्लोज कॉइल होने की वजह से फ्लो करता है, सिंपल इतना ही। और वो उसमें अपन लोड लगा देते हैं, कोई सा भी ड्रॉन कर लेते हैं करंट, सिंपल। और अगर इतना फ्लुएंसी देखना है तो देख, an AC generator consists of a magnet which creates a magnetic field and armature coil which rotates inside the magnetic field by means of the mechanical energy. When coil rotates inside the magnetic field, the magnetic flux changes. Due to this, EMF is induced in the conducting coil. As the coil is closed circuit, the current flow through the coil. As the coil rotates, the direction of EMF and current changes. The changing direction of the electromotive force after every 180 degree of rotation gives the alternating current. ये वर्किंग है एसी
अल्टरनेटिंग
जनरेटर
डीसी एसी जनरेटर।
की।
लेकिन मैं
एंड सिर्फ
एसी जनरेटर इज
एसी में
नथिंग बट अल्टरनेटर यार ना।
नहीं 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 नहीं
नहीं।
बोल सकते हैं, पर अल्टरनेटर थोड़ा अलग चीज है। अल्टरनेटर वो परमानेंट मैग्नेट यूज करते हैं अपन, वो ऑटोमोबाइल सेक्टर का अलग पार्ट होता है।
ओके
हम
बट
यूज कर सकते हैं पर करते नहीं, मेंटेनेंस ज्यादा होता है अगर एसी जनरेटर का तो।
ऑलराइट ओके बस करते हैं इसको। लेट्स मूव विद द नेक्स्ट क्वेश्चन। Okay, so the next question we have read is in our matriculation classes also, what is Ohm's law, and I think everyone knows about Ohm's law, that the V is V that came from the formula V equal to IR, that is the voltage between 2 points, across 2 points will be directly proportional to the current flow between 2 points at a constant temperature and other physical condition. All right guys, कोई तो बोलो ना, आगे बढ़ो।
हाँ कंटिन्यू।
ठीक है, एक बार मैं वो बोल दे रहा हूँ यार। मैं क्या कह रहा हूँ कि जब मैं सुन रहा हूँ तुम्हारा डिफिनेशंस ना, मुझे नहीं लगता मैं उतना पार जा पाऊंगा अभी। इतना ये जो है, जो तूने बोला ना किरण, कि जो रोटर रोटेट करता है वो मैग्नेटिक चेंज इन मैग्नेटिक फ्लक्स क्रिएट करता है, उसको ही मैंने शॉर्ट में यहाँ लिखा है। मतलब बहुत सारा बड़ा बड़ा एक्सप्लेनेशन आ रहा था, तो थोड़ा शॉर्ट्स में लिख दिया है कि एज द इन अ केस ऑफ जनरेटर, एज द रोटर स्पिन्स या रोटेट विद इन द मैग्नेटिक फील्ड, जो मैग्नेटिक फील्ड लगा हुआ है उसके अंदर रोटर रोटेट करता है, तो वो क्रिएट्स अ चेंजिंग मैग्नेटिक फ्लक्स। जो तू बोल रहा था कि मैग्नेटिक फील्ड को काटने की वजह से जो होता है क्रिएट, और दिस मैग्नेटिक फ्लक्स इंड्यूस एन इलेक्ट्रिक करंट इन द वायर वाइंडिंग ऑफ द रोटर। ठीक है, जो रोटर के वायर वाइंडिंग है, जो वायर वाइंडिंग है उसी को आर्मेचर वाइंडिंग बोलते हैं क्या?
हाँ
मतलब जैसे स्टेटर में आर्मेचर वाइंडिंग रहता है अल्टरनेटर के केस में, उसी तरह जनरेटर में, रोटर में जो वायर वाइंडिंग होता है उसको आर्मेचर
हाँ,
वाइंडिंग।
बराबर है बराबर।
बराबर है।
हाँ बराबर।
हाँ, ठीक है। तो उसमें रोटर में जनरेट होता है थ्रू इलेक्ट्रोमैग्नेटिक इंडक्शन। बस इतना ही बोला। अगर क्रॉस क्वेश्चन जाएगा गाइस, ऑल्सो बैकअप के लिए मैं वो दूसरा नोट्स में बना के उसको सारा लिख लूंगा। क्रॉस क्वेश्चन जाऊंगा तो मैं बता दूंगा क्या क्या है। पहले मैं
देख
छोटे से छोटे
मतलब
सा
किसी
रखूंगा।
के हिसाब से मत चल।
हाँ
तूने जो प्रिपेयर किया है किसी के हिसाब से मत चल।
हाँ।
मेरा क्वेश्चन अलग होगा, आईवीटी का क्वेश्चन अलग होगा,
हम्म
एक्सप्लेनेशन अलग होगा, तेरा एक्सप्लेनेशन अलग होगा।
हम्म
अगर तू तेरे एक्सप्लेनेशन में स्टिक करके
हम्म
जो क्रॉस क्वेश्चन आए उसके आंसर दे देगा तो चल जाएगा ना काम। तो
हम्म
दूसरों के हिसाब से क्यों सोचता है? तू
हम्म
तेरे हिसाब से सोचना।
हम्म
तूने नोट्स प्रिपेयर किए, तू तेरे हिसाब से डिलीवर कर आंसर।
हम्म
देख आंसर डिलीवरी हर एक की अलग होती है,
हम्म
हर एक टॉपिक पर।
हम्म।
किसकी वर्डिंग अलग होती है, किसकी सीक्वेंस अलग होती है। तो तू अपने हिसाब से दे।
और देख जैसे फराडेज लॉ ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन का था, मैं कितना सबका वर्डिंग सोचता था, लेकिन एक बार फर्स्ट फर्स्ट आई वेंट थ्रू ऑन बाय माय ओन एंड created my own definition, and that is very simple. When there is a relative motion between the magnetic field and electric circuit, there will be the induction of EMF.
ओके
The second is the amount of the quantity, the magnitude of that EMF will be equal to the amount of flux that is linked with that conductor, that electric circuit. Hmm?
ओके।
And third is that Lenz law. The third part
हम्म
of is that is Lenz law. It as we know the when when induction of EMF, when current flow through the wire, there will be the magnetic field. So in when from the Faraday's law electromagnetic, from the Faraday's law of electromagnetic induction, the induced EMF will have magnetic field. The induced EMF, the induced current will have magnetic field, and the direction of that magnetic field will be opposite to the direction of existing magnetic field. सही है
हाँ सही है।
यार, मैं बहुत लड़खड़ा रहा। एनीवे, ओम्स लॉ, I am going to read the definition of Ohm's law for clarification. Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across 2 points at constant temperature and other physical condition. Okay, and formula is V equal to IR. IR is the proportionality constant, that is resistance. Everyone know. Now coming to the Kirchoff's law. Yaar, the new guys have come. Pradyum, would you like to explain Kirchhoff's law? No. Anyone, guys? राकेश बोल ना कुछ। आई एम डूइंग।
मेरे पास इसका कुछ डेफिनेशन नहीं है फिलहाल। तू बोल, मैं लिखने वाला था।
Okay. So basically, there is Kirchhoff law is consists two laws: Kirchhoff current law and Kirchhoff voltage law. Kirchhoff voltage law states that the summation of the voltage across a closed loop in an electrical circuit will be equal to 0, and Kirchhoff current law states that the current entering to the junction will be equal to the current exiting from the junction or nodes. चलेगा?
ये वही है ना जो तूने कल समझाया था मेरे को।
हाँ हाँ हाँ, कि एक
तो
इसमें इलेक्ट्रिकल सर्किट में जो जंक्शन होते हैं, ठीक है, जितना करंट जाएगा उतना ही बाहर निकलेगा। ये एक किरचॉफ करंट लॉ है। यार, व्हाई आई एम यूजिंग सो मच हिंदी। ऑल राइट गाइज, now I am going to read the definition, the written definition. Kirchhoff voltage law states that the sum of all the voltage, sum of all the voltage. Kirchhoff's law states that the sum of all the voltage difference Kirchoff's law states that the sum of all the voltage difference in any closed loop in a circuit must be equal to the 0. Kirchoff current law states that the sum of current flowing into a junction or node will be equal to the sum of currents exiting the junction. चलेगा? All right. Now coming to the Faraday's law. Faraday's law. Subham, try to explain the Faraday's law. The session is being to yes, Sandhana, you like to try Faraday's law? Explaining Faraday's law.
Yeah, bro. Faraday's first law and second law. Faraday's has a two laws, bro.
All right.
Faraday's first law is whenever a conductor plays in a varying magnetic field, EMF is induced, bro.
Correct.
This is first law, bro. Right, bro?
Right.
Yeah, bro. Second law states that the rate of change of magnetic flux, the induced EMF is directly proportional to the rate of change of flux linkages, bro. This is Faraday's second law, bro.
Correct.
This is from my side, bro.
Okay.
क्या मेरा भी सुन ले.
हाँ,
Basically,
कोशिश करो सर.
Faraday has two laws. The first law states that whenever magnetic flux linked with the circuit changes, and EMF is induced in the circuit, which depends on the change of flux. This is the first law.
Again, repeat again, please.
Whenever magnetic flux linked with the circuit, and EMF is induced in the electric circuit.
Magnetic flux. Why are you saying magnetic flux? Magnetic flux is change in magnetic field, na? Kiran, correct me.
Yes.
Okay. So, just say na that whenever there is say instead of magnetic flux, say magnetic field and electrical circuit or set of conductors.
Okay, wait. Let me write it. So we can say like that, whenever magnetic field linked with the circuit changes and EMF is induced in the electric circuit. Is it okay?
Linked with? No.
Okay. That's okay.
कैसे? Kiran, electric circuit changes.
No. Whenever changing magnetic field linked with the conductor.
He just said opposite, na?
So basically, whenever changing magnetic field is associated or linked with the conductor, and EMF is induced in that conductor, and when the conductor forms a closed coil, the induced current because of the EMF flow through it. That's simple.
Okay.
Correct. Second.
And the second law states that the EMF induced in the circuit is directly proportional to the rate of change of magnetic flux with respect to time, which is minus d phi by dt.
Okay. Now I'm going to read it out. Okay. Explain Faraday's law. I will be saying in front of interviewer. Sir, Faraday's law defines or predicts the relation between the magnetic field and electrical circuit for an induction of EMF. Faraday's law consists of two laws. First law states that whenever there is a relative motion between a set of conductors and a magnetic field, then EMF will be induced. Second law states that the magnitude of induced EMF will be equal to the amount of magnetic flux linked with the conductor coil. That is given by the formula EMF equal to minus d phi by dt. Okay, minus n d phi by dt. And now coming to the Lenz law. Okay, Lenz law. I have already explained. Now I am going to read it out. And guys, initially I was having so much doubt in Lenz law, how his direction is opposite and opposite to whom. If anyone feels here, Pradyum, Sanna and Karthik, please cross question and we will discuss that. Okay. So Lenz law, okay, Lenz law is a consequence of Faraday's law, and it states that the direction of induced magnetic field due to the induced current will be opposite to the direction of existing magnetic field. Like there is a induction of EMF that is inducing current in the closed circuit, and that current will also produce magnetic field, because we know the concept of electromagnetism, that the conductor carrying wire will have magnetic field also. So there is an induction of current, so this current will also magnetic field. Now coming to the direction of magnetic field, this direction of magnetic field will be in the opposite direction of existing magnetic field, that is creating a induction of EMF, that is responsible for the induction of EMF.
Yeah, bro, right.
Correct, guys?
I understand.
Clear?
Yes, bro.
Okay, thank God. Yeah.
Clear, bro.
Like discussing with you guys, na. I hope Avito is not feeling bored. Avito, you can also try to explain like from. Okay.
Yeah, sure. No issues. I'm paying attention.
Okay. All right. And if Avito you have any better definition, yeah, any input, please halt me and please carry with try to speak up. Okay. Now coming to the next
Sure.
question. Next question. What is AC and DC current? Okay, guys. Anyone tries to explain? Otherwise, I am going to read it. Huh. Hi, Ajaz brother. All right. So AC stands for alternating current, and that direction changes periodically. DC stands for direct current, which has no direction. It flows only one direction. AC has sinusoidal waveform, that it has some frequency, and DC frequency is 0. Okay, and AC can be transferred to a long distance, but DC can't. And there is one difference I wanted to discuss with you guys, that in a case of AC it is written rotating magnet. In a case of alternating current, rotating magnet change the direction of flow, and in a case of DC current, direct current, steady magnetism makes the DC flow in single direction. Like my doubt is how the rotating magnet changing the direction of AC, like AC direction changes periodically, na, in a sinusoidal wave, in a in a sine form, in a sine function.
Sinusoidal wave.
Sinusoidal.
Pulsating flow.
Pulsating is DC. Okay, that is single flow direction. Okay, that is sinusoidal waveform. Okay, so the reason in AC rotating magnetic field, like the AC generator which in which the rotor is rotating, and so the magnetic field is rotating, magnetic rotor is rotating, and in rotor there is a armature winding where is a current induced. Because of that rotation in magnetic field, the current, that AC current is inducing, and because of that AC current direction is changing. Any reason? If you have heard anyone, Avito, Kiran.
Whatever you're saying is right, but in DC generator also same thing, but they will use split ring or commutator to continuously flow the current in the one direction, not in the reverse direction.
No, my question was like In a AC there is a changing of direction na periodically. Here it is written that because of rotating magnet it is happening. So I wanted to learn about the magnet mechanism of why it is happening. And anyway guys, let it be. Or someone is responding? No worries. So the next question is, what is transformer and how it is
Gyan, brother.
yeah.
Yeah, I have a doubt that you are mentioning that the AC is changing its directions. By the direction you want to mention is the fluctuations, right?
It has fluctuation, that is because of that it has
Uh,
fluctuation na? Plus
okay,
minus.
okay, okay.
Okay, yeah, it's fluctuate because
So
it has
Gyan,
frequency. Yeah.
one thing is when we say fluctuate, it might be the intensity of the current. So maybe we can say this change of polarity something. Because
Yes, it's
normally
it
when people fluctuating means that your tube light is becoming dark and becoming bright.
it's a change of polarity also na. What happens?
Yeah. So change of polarity is happening in the AC, this thing at a periodic time, whatever the 50, 60 hertz is there. But if we say fluctuation, it might seem that there is a drop in power as well.
Here we have heard this concept, this that AC has fluctuating current. That fluctuating means plus minus only. It fluctuates, it changes direction. It oscillates because of
Okay, so if
oscillation
you're
there na.
explaining that way, then maybe it should be okay then.
In what happen in AC na, suppose this is conductor, and if AC current is flowing, electron is responsible for the flow for current. So in AC what will happen na, suppose here is electron, the electron will oscillate from here to here. If it is oscillating here, suppose it is positive side, then it will come at mean position, then it will oscillate here. There is from here only we get sinusoidal wave. This is the microscopic concept of that AC current. Now come to the DC current. In DC current, electrons will be there. That electrons will be going like a shifting. All electrons will be happening through the battery and through the. It will not oscillate. All right, guys. Anyway, next question. What is transformer? Here, why I am forgetting the definition? I have to look here. What is transformer? A transformer is an experiment used to. Anyone like to
So it
speak?
is a electrostatic device in which
Hmm.
transfers of electrical energy, that is voltage and current,
Hmm.
take place from one circuit to another circuit without changing the frequency by mutual induction principle, which
By
itself
principle of
works under the
mutual
principle of
induction.
huh,
But you said,
was it?
it will not change frequency and voltage. Yeah, it is not weird because in transformer we have a step up transformer, a step down transformer that
It
changes
only change the voltage, not the frequency.
voltage.
Yeah,
All right. Okay. So what is principle of mutual induction?
that Faraday's law, I think so.
नहीं. Kiran,
अरे यार,
what is principle of mutual induction?
if you know, please let me know.
The
What is that?
there is
Mutual
next
induction.
question. Next question. Yes, there is a list of question in which there is a question. What is principle of mutual induction? What is self induction? Everyone is okay. And thank you just remember made me remember that I have to also write its principle. Okay. So you told it right that transfer is a device electrical device that transfer electrical energy from one circuit to another circuit, okay, through electromagnetic induction. Or who says that the principle will be principle of mutual induction? Guys, transformer principle is what? Avito? Kiran? Why Kiran is not speaking? What is the principle of
I think simple म्यूचुअल नहीं सिंपल प्रिंसिपल है म्यूचुअल भी है ना
अरे
देखना पड़ेगा
इसमें
रुको
लिखा है
मिनट
सुनना
रुको
a transformer is an electrical device that is used to transfer electrical energy between two or more circuits through electromagnetic induction. It consists of two or more coils of wire known as windings that are wrapped around a core made of iron or other magnetic material. Working principle: when AC current flows through the primary winding, it creates a constantly changing magnetic field in the core. This changing magnetic field induces a voltage in the secondary winding through electromagnetic induction.
म्यूचुअल इंडक्शन फैराडेज म्यूचुअल इंडक्शन
तो दो प्रिंसिपल होगा इसमें, एक तो इलेक्ट्रोमैग्नेटिक इंडक्शन के
दोनों है ना
दोनों है ना,
एक तो इलेक्ट्रोमैग्नेटिक हाँ दोनों ही इलेक्ट्रोमैग्नेटिक इंडक्शन की वजह से वो करंट फ्लो करेगा और म्यूचुअल इंडक्शन की वजह से वोल्टेज फ्लो करेगा वोल्टेज एंड करंट
म्यूचुअल
दोनों
इंडक्शन की वजह से एक सर्किट में दूसरे सर्किट में वोल्टेज इंड्यूस होगा, है ना।
बराबर
एंड चल मैं लिख लेता हूँ इसको, ठीक है। म्यूचुअल इंडक्शन इसके बाद पढ़ेंगे हम, लेकिन मुझे लग रहा है इसमें आई एम फीलिंग दैट when AC current flows through the primary winding, it creates a constantly change in the magnetic field in the core. This changing magnetic field induces a voltage in the secondary winding through electromagnetic induction. Induces a voltage. यार इसको मैंने उसमें डाल दिया ना, इसको अच्छे से करूंगा, उसके बाद आते हैं नेक्स्ट मीटिंग में इसको डिस्कस करेंगे। And now the question is how it transfer electricity in our home. How transformer transform electricity in our home. As we know, in transformer first high voltage is created from the power plant, then we have substation, from there we use step down transformer, from there voltage is bring down, then it supplies in our homes. Okay, let me read it out. The electrical energy generated at power plants is transmitted over long distance at high voltage to reduce power losses. So high voltage is why we use high voltage in transmission line, because of the reduction of power loss. Okay, so at local distance,
transmission losses
power loss and transmission loss is same thing, na?
yes
Okay. So at local distribution substation, transformer step down the voltage to a suitable level for residential use. This lower voltage is then supplied to our home. Okay. Now there the question is coming is very short answer. Okay. So these are all the interview question that we are discussing. So since we are discussing, the people who don't know will get to know little bit now. Then after they will do their homework, then we'll clear their concept. So the next question is how many volts come to our home and of what frequency? Anyone? Karthik, you are not speaking.
230 or 440 to
yeah volts and
to 240.
220 voltage and 50 hertz.
230 voltage and
Beda
50 hertz. And jackpot said 240,
right.
no, 230 volt, 50 hertz. This has been asked here, so remember this. Okay. The next question is now, how much voltage and current does the transmission line carry between power generation and customer? It is clear that high voltage and lower current. Okay, but how much voltage approx?
11 kV or 22 kV.
Yeah, 11 kb to 33 kb. You know what? From the power station, it is generated 11,000 volt to 33,000 volt. But in a substation, in the middle of substation, where it is stepped up to the lakhs of volt, and then from coming to the our residential areas, the transformer, it again comes to the 230 volt. But I have skipped that substation part voltage, that is in lakh volt, but I will be saying this only. Sir, at power generation, it is generally generated voltage is 11,000 volt to 33,000 volt, and coming to our home, the it gets converted step down into 230 volt. That is high voltage current comes, high voltage and with lower current. But while lower current, in lower current there will be the losses. When there will be the high voltage, na, there will be the lower current. Any clear concept behind this? Why high voltage and lower current?
So I think mainly the thing comes from heat, which is VIT,
Hmm.
the formula of heat.
Hmm.
So you can make V into IR, so you'll get I squared R.
Hmm.
So if current increases little bit,
Hmm.
it's squared, so your heat will massively increase. So that's why we try to keep current low and voltage higher in the power lines, etc. That's why we keep current high
Exactly
in
the
transmitting
reason
over long distances.
what I have learned, but due to unable to explain like you, I just V equal to I square RT. Yeah, na, power equal to I square RT. What is V equal to IR, na? What was the formula, yaar?
I think H, which is heat, equal to VIT.
VIT. Okay. I square RT. That is also equal to I. So, oh, so to minimize heat losses, what to say? What was the answer? Like clear answer?
So in this formula, we
Hmm.
see heat
Hmm.
is proportional to the square of current.
Hmm. Hmm.
So if current increases little bit,
Hmm.
in the formula it is squared, so it will become a huge impact on heat.
Hmm. Correct. I
So
square
that is why
RT.
we keep the current lower
Hmm.
and voltage more.
Uh, Correct. Okay. Any cross question regarding that? Okay, coming to the next question. What is diode, and explain zener diode? So diode is an electronic device. What is an electronic device? Electronic device that works with a small current, on a small current. Okay. So it is an electronic device that converts AC current into DC current. What is zener diode? Zener diode is a special type of diode that is used to maintain a constant voltage in a breakdown region. What is breakdown region? Breakdown region is that voltage region when current flows in the reverse direction, all of sudden a threshold crosses and the voltage gets increased. So to protect that, we use zener diode to maintain constant voltage. Am I making sense, guys?
One correction in a diode, brother. Actually, you said diode is converting. Yeah.
One by one, guys. Karthik, go ahead. Sandhana, please mute
No, no,
yourself.
then go space.
Huh?
Bro, one second, bro.
Sandhana, please
That
mute your. Okay. Karthik, please.
Yes, yes. Actually, you said for it convert AC to DC or DC into AC, like that you don't know. But that is for this bridge rectifier, these things. That's totally different. The base thing is it was current in one direction only.
That's why this discussion meeting is required.
Yeah,
And all of my memories. Thank God I am making mistake
no
in you
problem.
with
No
you
problem.
people. So a diode is a semiconductor device, electronic device that allows current to flow only in one direction.
Yeah.
Okay, that what I
And the
said
zener diode is
was
actually,
the definition of rectifier. And for Zener diode, I said it right now.
yeah, it's
Okay.
absolutely right. Even I too don't know these points.
Okay. And thank you, yaar. A diode is a semiconductor device that allows current to flow only in one direction. Only in one direction. Which direction, guys? Forward bias direction. Generally, typically. Now coming to the Zener diode. A Zener diode is a special type of diode that is used to maintain a constant voltage across a load even the input voltage varies. Okay, it is designed to operate in the reverse breakdown region. I just explained what is breakdown region. Breakdown region is that region where all of sudden voltage get increased. You must have heard, have seen this diagram. I don't know. It is really worth it to explain it here. Seeing the
like a S shape, right? Where infinitely it'll increase suddenly.
you're seeing that uh, you're seeing that all of sudden it is going like this in a reverse,
Straight down.
straight down. All of sudden from 50 to 100 voltage it takes. Okay. Now coming to the this question, what is rectifier? I have already explained. Anyone like to repeat, please? Rakesh, go ahead. Why are you not speaking?
Just explain again, bro.
रेक्टिफायर एक लाइन का था यार, बोल. रेक्टिफायर, व्हाट इज रेक्टिफायर? फिर से बोल देता हूँ. ओके, लेट मी. रेक्टिफायर दैट कन्वर्ट एसी इनटू डीसी. ओके, इट इज एन इलेक्ट्रिकल डिवाइस, इलेक्ट्रॉनिक डिवाइस दैट कन्वर्ट एसी इनटू डीसी. ओके, एसी करंट इनटू डीसी करंट. करेक्ट. हम कहाँ यूज करते हैं इसका एग्जांपल क्या है? अल्टरनेटर में. याद आया? इन अल्टरनेटर, we
हाँ
use
ठीक है.
diode rectifier assembly. Rectifier. And because we cannot charge battery with the
To
AC
charge
current,
the battery,
we cannot store AC
AC
current,
current. Yes,
AC current in the battery na. Jackpot has something to say. Yes,
yes,
jackpot.
yes.
Are you sure about they will use diodes
Diode rectifier
in the
assembly.
alternator?
Diode rectifier assembly, the whole name. But I am not going to uh, uh, get trapped here. I'm just cutting the diode thing.
Because if their diode use voltage can't be controlled, the voltage will be varies. That's why I'm asking.
Maybe see, alternator is producing alternating current na, and this alternating current has a different direction, like a changing direction, to make it flow in one direction. And also DC, along with DC direct current, means. So that's why we are diode
No.
rectifier.
It's not like that. I'm asking the voltage flex. The voltage will be fluctuate if you're using only the diode.
No, yeah, for diode, diode works.
Yeah,
So for what? Zener diode or simply diode?
simple diode.
Diode, what was it? Actually, what diode does, it uh, allows flow only in one direction. Okay, and blocks the flow in other direction. No idea, bro, if voltage fluctuates or not. But according to
No, I
what,
have done my practicals in my schools. If you use diode means the voltage will be fluctuate.
voltage will be
There will be no constant voltage. Fluctuate,
fluctuate.
increase and decreasing. There is no constant voltage.
There will be no constant voltage. So
Yeah,
so that's
Jackpot.
yes.
Jackpot. I think if I remember my practical
Hmm.
in the rectifier, we will get all upside down. So some kind of power drop. Then to compensate, we add some kind of capacitor or something. to try and
and
smoothen out the
induction
power
to
curve.
filter the hikes.
Yeah, so be in the car also like that might be there, but just talking about of AC. But maybe a good idea to check out some kind of
Avito, your
smoothening
voice is lagging.
by some lagging.
Your voice is lagging little bit.
Wait a 1 minute.
Mm. So the conclusion made
It's still
by the
lagging now.
jackpot is that in diodes voltage fluctuates. Now I'm searching for it. Come on. Yes, now it is all okay.
Yeah, so that's what I'm saying because
Mm,
even in my electrical class, I had to, simulate basically half
mm,
wave, full wave, all of those
mm,
rectifiers.
mm,
And in that, they add the capacitor to try and smoothen the power curve. So I think that is what
mm,
Jackpot is asking, and whether
mm,
that would be healthy on the life of the battery,
mm,
or
mm,
could that cause some harm. So in that case, maybe after the alternator, something else could be there that
mm,
can help rectifier to smoothen the
mm,
voltage produced in DC.
mm, okay. The voltage across a diode can fluctuate depending on various factors such as change in the current flowing through the diode, change in the temperature, and change in the characteristics of diode itself. In forward bias, when the diode is conducting, the voltage drop across the diode is relatively constant over a range of current. However, small changes in the current flowing through the diode can cause the voltage fluctuate slightly. In reverse bias, when the diode is not conducting, the voltage across the diode can vary widely with the change in temperature or change in the reverse current flowing through the diode. Overall, while the voltage across a diode can fluctuate to some extent, its behavior is generally well defined and predictable within the given range of not very much, yeah. You cross check your na from your side. Okay, coming to the next question, we have just
If you are using diode, don't use. Uh, if you are using rectifier, don't use diode.
so
The
I
word
have
diode because
yeah, I have
rec-
just cut in a case of alternator. I will be speaking only. There is a rectifier assembly which is converting AC and into DC. Okay, and, earlier I was about to
yeah,
explain diode.
that's sounds good.
Yeah, correct. Thank you. So diode we have just read that it is used to uh, block the flow of direction of it is used to it is used device that allows current only
Converts the AC.
no diodes that allows current flow only
Sorry,
in one direction, rectifier to convert AC into
sorry,
DC. Okay, now coming to the this
DC.
point, half wave rectifier, full wave rectifier. I have not written it in very detail. There was a graph and all. So half wave rectifier means converting half cycle of alternating current into DC into
DC
DC.
current.
Okay, in full wave, all the cycle complete cycle is getting converted. Like some pulsating curve will be making up. Okay, in a half wave and full wave a constant. Anyway. The next question is single phase induction motor. It has been asked single phase induction motor, three phase induction motor. So first let me try what I have learned, and now I will be reading up thick. And so as the name suggests, single phase induction motor. Single phase means uh, it is it works on the supply of single phase alternating current, and the working principle is induction, electromagnetic induction. And since it is motor, it convert electrical energy into mechanical energy, yeah. And it is used in a small industrial area. It is used in residential areas for residential purpose. Uh, Now I am going to read a definition. Yes, I know I have made a mess. Now I am remembering the other thing which I have read. I have also read that in single phase induction motor there is a need of auxiliary component, because the starting torque in a single phase induction motor will be less. So that's why we need auxiliary component like a centrifugal switch, or 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 what. Let's see what it is. Yeah, why it is tough to remember. A single phase induction motor is an electric motor that operates on a single phase AC power supply. I was correct in this line. Okay. Now coming to, it is a type of induction motor that uses electromagnetic induction principle to generate a rotating magnetic field and induces a current in the rotor that drives the rotor and produce mechanical energy. Single phase induction motor requires auxiliary components to generate magnetic field. They are mostly used for low power applications such as household appliances. Example: fan, refrigerator, washing machine. Now I am, anyone having idea about single phase induction motor? Any common and can add something? Karthik, Ejaz bro.
Can you repeat the last
Yeah,
line what you have said about the home
they
appliance?
they are mostly used for low power application.
And they are not the
No,
self-starting.
auxiliary components like
Okay,
what?
okay, okay. Uh, First I am going to explain in Hindi यार. Then after I will try to explain क्या होता है इसमें. इसमें क्या होता है कि सिंगल फेज इंडक्शन मोटर में सिंगल फेज एसी सप्लाई पे ये काम करता है. ठीक है. और ये इलेक्ट्रोमैग्नेटिक इंडक्शन इसका प्रिंसिपल होता है, जिसके वजह से रोटेटिंग मैग्नेटिक फील्ड इंड्यूस करता है करंट इन द रोटर, जो कि जो है और फर्दर चूंकि मोटर है तो मैकेनिकल एनर्जी में इलेक्ट्रिकल एनर्जी मैकेनिकल एनर्जी में कन्वर्ट होता है. ओके. सो वहाँ से हम वर्क डन प्राप्त करते हैं. अब कमिंग टू दिस ऑक्सिलरी कॉन्सेप्ट, क्या होता है कि जो जनरेटिंग मैग्नेटिक फील्ड होता है इसमें, जो रोटर पे जनरेट होता है इलेक्ट्रिक मोटर के, उसको वो उतना नहीं होता है इनिशियली, क्योंकि सिंगल फेज पावर सप्लाई मिल रहा है. ये 3 फेज हम जब पढ़ेंगे तो समझ में आ जाएगा. तो इतना नहीं होता, उसके वजह से हमें ऑक्सिलरी कंपोनेंट चाहिए होता है उसको जो है स्टार्टिंग टॉर्क ज़्यादा करने के लिए. और मैं इतना डीप में नहीं जाऊंगा कि क्या चाहिए होता है. उसमें सेंट्रीफ्यूगल स्विच होता है. वो सेंट्रीफ्यूगल स्विच जो होता है वो स्टार्टिंग में को प्रोवाइड करता है सम थ्रेशोल्ड, सम टॉर्क, एंड फिर कांस्टेंट कर देता है तो स्विच ऑफ हो जाता है. ठीक है. नाउ कमिंग टू द in English thing, that the single phase AC single phase induction motor is a AC motor that works on the AC single phase AC power supply. The principle is electromagnetic induction. Okay. And that induces the current in the rotor via generating magnetic field. And this in a single phase induction motor will require auxiliary component, because in single phase induction motor the initial torque in the rotor will be less, so it is less efficient, low power application. That's why it is using in low power application. It has 2 winding, basically primary winding and auxiliary winding. Yes, jackpot.
So that's why in fan we use capacitance, if you are correct.
So capacitor, yeah, capacitor is nothing but what? Capacitor is a which stores energy and supply all of a sudden, like in a sudden in a fan. Capacitor, that condenser, what does do? It store electric field, it store energy in the electric field and supply all of a sudden.
To compensate the torque, right? Initial torque.
Initial torque. Otherwise, earlier without capacitor, fan was starting like this, very slow, very slow. Then after some time, it take constant. RPM. Got it? So auxiliary component.
So one more question is,
Question
if
is.
we are claiming the capacitor, uh, yeah, if we are claiming capacitor only for the initial part, then why do we say that if the capacitor is spoiled, the fan will spin slowly, like total, not only at starting, but the full time?
I am not going to say capacitor. I will say centrifugal switch. Maybe this initial working because centrifugal switch gets turned off in this single phase induction motor. I haven't gone in very deep, otherwise I will be very confused, made myself confusing. But I have studied about this in because initial torque will less in this single phase induction motor, because so that's why we use as a auxiliary component, that is centrifugal switch. After that, after reaching at a constant RPM, constant torque, the centrifugal switch gets turned off. So the Avito concept that across question was like, why we keep switched on capacitor now, like why all the time capacitor is on, is that only now?
No, 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 no.
What was your question?
See, my question is, we are saying that the capacitor is responsible for the initial torque,
Hmm.
right? So it helps the initial torque so that the fan can start to spin.
Hmm.
But what I've observed is, if the capacitor is spoiled,
Hmm.
the fan can never reach its high RPM. So that means, is the capacitor being used again and again? So like imagine, like small powered shocks, like tuck 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 tuck. It just gives it high current so that the fan can spin faster or something. Like, what is the frequency of the discharge of a capacitor in a fan is what I would like to know. Maybe I have to do some more work on that.
As far as I know, we use capacitor to like provide uh, collective energy, like to store energy that can be used, like and I really didn't get your question. We'll discuss on that. What could be the
Yeah, I will go in the group.
so yeah, coming to the next question, three
But for
phase.
now, just to keep it as per the interview, it's going to be that the capacitor is
Yeah.
used to help compensate for the large initial starting torque required.
But here we are having as an auxiliary component centrifugal switch. Centrifugal switch gets turned off when the starting component, starting torque of this single phase induction motor rotor is become constant. Okay, now coming to three phase induction motor. I am just giving you basic ideas what it is, and guys, you have to revise by yourself. I will be also sending the PDF of my notes. Okay. So coming to the three-phase induction motor. A three-phase induction motor is an electrical power motor that operates on three-phase power supply, which is commonly used in industrial and commercial application. It works on the principle of electromagnetic induction, which produces a torque on the rotor, causing it to start rotating. It has self-starting mechanism, unlike single-phase induction motor, because of higher torque produced in the rotor. Correct? Yeah, it does not require any auxiliary component. It is a self-starter motor. Three-phase induction motor, single-phase induction motor. Single-phase induction motor, that uh, is an electrical motor that operates on a single-phase power supply. Three-phase induction motor that operates on a three-phase power supply. In a single-phase induction motor, it will require auxiliary component to uh, to give a start. It is a self-starting motor. It has self-starting mechanism because it produces higher torque in the rotor through electromagnetic induction. It also works on the principle of electromagnetic induction, but the generating it generates lower torque at the rotor because of the single phase supply or whatever the reason, I don't know. Correct? Basic idea, superficial idea. That is what I am going to say in front of interviewer. I am not going into very deep. Okay, guys, the next
But if he asks
what he will ask any cross question.
working of leverage,
See, Rakesh and everyone, guys, please ask any cross question. If I am giving you the leverage, like if I am using some words that is not common to you, that you think you can ask what is that auxiliary component is what, so I can explain that. I am also taking the word responsibilities, which are the word I am speaking of, I should know about that. So that much I know, that much I have prepared for myself. You can ask, okay, but I am not going to very deep into how is the mechanism, what are the parts and all, for the time being. Okay, the next question is how current is produced in the alternator. We have already discussed about this. As the rotor rotates in the alternator, firstly we will tell the one line answer is that because of electromagnetic induction the current is produced, and he will say how it is produced. Then we will go through the concept that it consists of rotor, stator and diode, and rectifier. So when the rotor rotates, it creates a magnetic field, and that generates the current, that induce the current in the stator windings. Further, it is converted into direct current, something like that, very short. So what I have written, the alternator current is produced in an alternator through the process of electromagnetic induction. The alternator consists of rotor, stator and rectifier assembly. As the rotor rotates, it creates a changing magnetic field that induces an alternating current in the stator winding, which is then transmitted out of the alternator as a electrical power. Correct, guys? Any cross question you want to ask in that, you can ask. Okay, this was the common question. Now coming to this question, it has been asked, difference between the speed of motor and frequency of current. Have you heard of this question? Anyway, so you must have heard.
I think yeah, on the Instagram, I think there's some
Okay.
person, right, who had got this question.
But I doubt, because it should not be the exactly question like this, because it is interrelated. We have a one formula that is n equal to 120 into f upon p. N is the speed of the motor, 120 into f. F is the frequency of current, p is the number of poles. Okay, so it is interrelated. And now coming to the speed of motor, so if it has been asked to me, it will ask to me, I will just define the speed of motor and frequency of current, what it is, and also will say that sir it is interrelated. This is the formula, and S is the synchronous speed, that is the speed of motor, 120 equal to 120 in the f upon p. P is the frequency of current, and also speed of the motor is what? Yeah, I am referring about the speed of the rotor, rotational speed of the rotor or motor shaft. Okay, frequency of the current, I am talking about the alternating current having completing its cycle per second, number of oscillations per second, completing its cycle per second. Frequency, clear, guys?
Yeah, so maybe to make it even more clear for the interviewer, you can then give an example stating that after you give your interrelationship, what will happen to the speed of the motor if I increase the frequency? What will happen if the frequency?
It will also increase.
Yeah.
It is directly proportional, sir.
Yeah, so you can just give some example like this just to clarify that you have understood the interrelationship in terms of what will happen in real life.
Yeah,
you can just say assuming constant poles or whatever.
Yeah, if we are having a fixed number of poles in the motor, and if we increase the speed of the rotor shaft, then the frequency of alternating current we are getting as an output will increase. Correct, Evito? Okay.
One second, you are cutting out.
Okay. I have just
So you're
said,
saying directly proportional, right?
yeah, thinking that the number of poles is fixed. The number of magnetic poles is fixed. Okay.
Okay.
Okay. The next question is, what do you mean by RMS? First, guys, tell me the full form of RMS according to electrical.
RMF or RMS?
Yes. Full form of RMS. Yes,
I think root means square.
root mean square. Karthik, earlier you used to use your camera. Now you have just shut off your camera. You can come on. I am feeling like just monotonous in the.
Yeah,
Okay.
yeah, understand.
Okay.
I don't know what happened.
No problem. No problem. So, if he will be asking what is RMS, so let me try. Sir, RMS stands for root mean square. It is a generally it is used in it is a mathematical concept used for effective value of voltage and current. The RMS value is more convenient in yeah, in electrical concepts. Let's see what it is. RMS stands for root mean square. I was right. It is mathematical term used to describe the effective value of varying quantity, effective or average value. So RMS is effective value of varying quantity such as voltage or current. It is used to calculate equivalent DC value of an AC waveform. It is used to calculate equivalent DC value of AC waveform, AC current. Guys, you are understanding the last term? I have, yeah, I should make a
Yeah,
clear.
that means you're saying how we measure this roughness. We in mechanical terms we use RA and RZ because roughness can't be constant. It keeps on varying. Like this in electrical also the voltage and these things keeps on varying. So we use this term RMS, right? Am I making sense?
Please again, I didn't go to, I just lost you. Yes?
Yeah, okay. In mechanical, for measuring the roughness, we use this term RA and RZ. It is also quite related to mathematical thing, right? Because it's keep on changing, and we give some mathematical results to get perfect value. Like this, we are relating to this electrical also RMS.
Yeah, the analogy is quite similar. We use the same analogy, okay, because it's always varying, okay. So we need some average
Yeah,
speed, just like a mean effective speed in a case of engine, okay.
yeah.
Uh,
A particular
Mean
value.
effective pressure was mean effective pressure, okay. So it is like that, and it also tells, it is used to calculate the equivalent of DC value of an AC current. Like if AC current is generating that much heat while flowing in a conductor, what would be the DC current generated? Then we can use the RMS value, that is the effective value. But I will be speaking only this two line. It a root mean square, and it tells about the effective value of voltage and current. Okay. Yes,
Okay.
Pradum. Yes, Pradum. Go ahead.
Do interview really going to ask us the questions that deep?
Yes, I have collected the question from the testimonial only. We cannot leave that on the just on luck. We should have some idea about this. If any cross question also comes, if we explaining something, then we should know na actually what it is. So that's why we are just mugging up and knowing the things on a superficial level, not going into very deep. It's an electrical thing. Will be mechanical. If there will be the mechanical thing, we always go in very deep. Okay. Okay.
Okay, got it.
Okay. The next question is, why voltage is stepped up for transmission? One word answer it has. Why voltage is stepped up for transmission? Anyone, guys? Rakesh, try.
To reduce that power loss
Correct.
and transmission loss.
Yes. Because to reduce power loss during transmission. The next question is why generator rating in kilovolt ampere, not in kilowatt? Rakesh, anyone? Ajaz brother, you are just
Sorry, bro, I don't.
okay. Okay, now you will know why we measure kilovolt kVA na kilovolt ampere as a generator rating, because it's take into account the reactive power. The word is reactive power that is required to run electrical equipment. Just a second. So we can memorize this concept just by knowing the fact that the generator is used to run the electrical equipment. So to run the electrical equipment we need the rating for that kilovolt ampere. So that's why we use kilovolt ampere for generator rating, generator power rating. Okay, kilovolt ampere, not kilowatt. Okay, kilovolt ampere, because it is it
Can you
account.
come again?
Can repeat करिए फिर से.
No. Listen, why generator rating in kilovolt ampere, not in kilowatt? Because kilowatt volt ampere takes into account the reactive power. Like if we are telling in a kilovolt ampere, it also associate it with reactive power. And what is reactive power? Reactive power is required to run electrical equipment. So one word answer can be like this: why generator rating in kilovolt ampere? Sir, because of reactive power. Why? Sir, because reactive power is required to run the electrical equipment. So if we are running the if we are using the generator to run electrical equipment, so as we know that the reactive power is required to run that, so we to synchronize with that we should know what is the generator power of generator rating on that. It is very new concept to me also. Reactive power. Reactive power is the power
Yeah,
required.
because cross question might come is that all of the appliances that you're using will be given in watts. Like if you have an iron or geyser or whatever, those
Yeah.
are mentioned in watts. So you're saying that appliances, and again we are going to kilowatts. I mean kilovolts. So some more clarity, I think we'll have to dig up on this answer.
Yes, yes, I have to. Thank God, Vito, you just rightly put your cross question. Okay, so we'll discuss that later about that. Reactive power is the power required to produce and maintain electric and magnetic field, which are needed to operate most electrical component. Electric field and magnetic field. Cross question is why we use. What about running the equipment having power is in watts? In watts. I don't have the answer right now, but I will go for that. Now coming to the answer question, advantage of AC over DC. Okay, AC, alternating current, direct current. The first advantage will be it can transmit it up to long distance with minimum power losses, and AC current is widely used than DC current. And the important to remember thing is that the AC current can be easily stepped up or stepped down using transformer. Correct, guys? The next question. This is an important question, and that can be asked: why AC can't be stored in batteries? Why alternating current can't be stored in batteries? Pradyum, Rakesh, anyone, guys? Try to speak up. We have just in the initially in the meeting we have discussed a little bit about this, why alternating current can't be stored in the battery.
Batteries have a constant polarity, it won't change polarity, but the AC current will change the polarity and change its direction.
Correct. So then to store AC in battery, what we have to do?
We have to rectify it.
हम्म हम्म राकेश तू ट्राई नहीं कर रहा है, ठीक है. So AC can't be stored in, you have told right. I am just reading the structural answer. AC can't be stored in batteries because batteries store electrical energy in the form of chemical energy. Okay. AC on the other hand is a form of electrical energy that constantly changes the direction and amplitude over time. To store AC in battery, it would need to rectify first. Okay. Because of changing direction. Okay.
Gyan, one question.
Yes. Cross question you ask Avito. Any cross question that
Yeah,
can be
the
asked.
cross question. Cross question is not cross question. It's just like a slight this thing correction. That can the rectifier do DC to AC? Because that is only diode. So how will it give me that pulsating 60 hertz? Diodes cannot give me the 60 hertz. So we'll need some other device. I think invert something.
Can you come again, Avito?
So
I
we know
didn't
that
get the question.
yeah. So we know that alternating current has a frequency.
Yeah,
In my DC, which has no frequency, constant.
yeah.
So just a pair of diodes in case of the rectifier create this perfect 60 hertz frequency. What if I want 50 hertz frequency? How can I change frequency by just keeping diodes? So is rectifier the setup, the assembly that I have to use to go DC to AC, or rectifier only do AC to DC?
Rectifier can only use to convert AC to DC. It can't convert DC to AC.
But
If you want to DC to AC, you have to use inverter.
and what is the principle of inverter? Yeah, here this can be the question, cross question, possible cross question. I need to write it. Mm.
And for rectifier, we won't use diodes. We will use like switches like AC or most probably. We can control the switching operation by giving the impulse during the correct frequency. So it can be directly take the output in a single line.
Okay, so basically now we know that the rectifier will be used only from AC to DC, but DC to AC, which means when we are using power from the battery, we need to first send it to an inverter, similar to what we have in a house. That is why that is also called inverter.
That convert DC current into AC
Yeah,
current.
that's
Yes.
inverter.
I am going
Yes,
to do
because
the first
battery
thing.
is stored in DC, and this could be a great example. Or you can say where is inverter used. So you can say I have it in my house when power goes off.
Yeah.
It is powering the TV, light, fan, everything. So inverter, and the name is
So
given perfectly.
yeah, correct. Inverter basically convert DC energy into AC energy or chemical energy into AC energy, because it store energy in the form of chemical energy, isn't, guys?
Yeah, in form of ions.
See, there is different types of chemical energy. I can say that chemical energy has been converted into it also in some process of reaction. So in this case, I need to specify that the energy that I'm talking about is DC in nature before the inverter.
I will read about that. All the concept DC to AC. Okay.
Yeah.
uh, just writing it for the next session. Now coming to the next question, what is Coulombs law? Just speak about the formula. Yeah, Rakesh, try.
Formula is K Q1
Hmm.
Q2 R this square.
Upon R
Okay,
square.
and the relation for that is, yeah, Coulomb's law states that the force of attraction or repulsion between two charges object is directly proportional to the product of their charges and inversely proportional to the square of distance between them.
Correct, correct. Coulomb's law states that the force between two
So
charges.
here, not a cross, just asking.
Yes, yes, yeah.
Yeah, is there to the law of gravitation
Yeah,
between
similar to
two
the
objects?
law of gravitation analogy, but it is similar.
This is
The
just for
analogy,
charges.
yeah, for charges it is similar, and there was some difference in this concept, but analogy is similar. Okay. Law of gravitation is the attractive force only. It is attractive as well as repulsive only. If the charges having the same sign, it will repulse. Opposite signs will attract. Okay.
Oh, so that is a slight twist in this. Okay,
Okay.
got it.
And Avito, just I am very happy that you are here to put up any cross question after this concept. Please be active, na? Okay. So Coulomb's law, we have just stated that the force between two charges charge particle is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. F equal to K Q1 Q2 upon R square. K is the electrostatic constant. What is that? K is the Coulomb's. K is what? Electrostatic
Coulomb's
constant.
constant.
No. K is the Coulomb's yes.
Elect-
K is Coulomb constant. Sorry. Now coming to this important question. What is the difference between voltage and EMF? Okay, Pradum. Take care and no issues. We'll share the recording with you all people. Okay. No worries. If only two people will be there, I am going to discuss anyhow. No matter what the time is going on, time will pass. No matter what the time, I am not able to complete the sentence, but understand my feeling. So the next question is, what is voltage and electromotive force? What is the difference? The concept of voltage and electromotive force. Rakesh, try na. Little bit something.
Electromotive force, that the maximum voltage that can deliver.
I will tell you because that why your point is right, but is not the correct definition. Karthik, Jack.
Yeah, actually, the EMF and voltage both having same units, and voltage is related to potential difference, and EMF is related to this galvanic cell, like that. The movement of, I think.
90% correct. Jack.
Both are same only, I think so. Because they used to make the current flow in one direction, make current flow.
Hmm. Both are same. Then why we use different names? Okay. Ejaz, bro. Ejaz, bro. You are not speaking up at
Idea.
all. Yeah.
I don't have much idea about electric person.
Electricity, but you
Sir,
should
only
na
sir here.
try it na. Try it what you have just listened, because I want you people to memorize it. Just right here you will be
Okay.
benefiting
Actually,
now.
EMF is created by rotating a in the magnetic field.
And what is voltage?
I don't
ना
know.
डिफरेंस दो इलेक्ट्रोड का जब करंट नहीं हो रहा होगा ऐसा कुछ
Now it is very different. It is the same.
potential difference.
Both are potential difference. Both are potential difference. Voltage and EMF are both measures of electric potential difference, but they have different meaning and concept. Like, you know what? If we are saying that voltage difference means we are having the difference between 2 points in an electric circuit, difference of voltage in the electric circuit. If we are saying the electric motive force, there will be battery, and that will producing the voltage difference between 2 points. So suppose A and B, suppose a electrical circuit with a battery, okay, and this is coming to the wire, and we have resistor between them, load A point, B point. So the voltage difference between A point and B point will be the potential difference, and the voltage difference in the battery will be the electromotive force. And the one thing you said, Rakesh, that the electromotive force is the maximum voltage difference, voltage difference or something like that. Yes, it will be the maximum because it is coming from battery, and there will be the some losses, internal losses, because of there will be some drop in voltage because of the external factor in the wire, because of internal resistance and all. So that point was right. Now I am going to read the definition. Karthik was also right. Jack has also said the same. It is the same thing, same thing, but the concept is little bit different. So voltage is the potential difference that exists in a circuit due to the presence of voltage source. Voltage is the potential difference that exists in a circuit due to the presence of voltage source, while EMF is the potential difference that exists in the voltage source itself. Voltage difference is the potential difference that exists due to the voltage source, and electromotive force is the potential difference that exists in the in the voltage source itself, due to in the cross
Okay,
question.
makes sense.
Cross question.
By the voltage source, in the voltage source. It's a
Yes,
difference.
yes, correct. Away to cross question.
So we need to say by the voltage source in the circuit.
Yeah.
So what I was saying, that one way to imagine this will be like, in case you take your multimeter, and if you measure just between the batteries, I mean just the battery, terminals, that value that you get will be maybe EMF,
No,
and then if you measure the voltage,
we are having the EMF is given by the manufacturer. Now we are having 6 volt battery, 2 volt battery, 12 volt battery. That is called EMF.
9 volt. Okay.
That 9 volt battery is generating how much potential difference, we'll get to know by the current flowing through it by using ammeter, and the resistance by using resistor, or that is multimeter, that can direct it till the potential difference between them. And if we are using 9 volt battery, there will be the potential difference between them less than 9 volt battery, because of the resistor, external resistance,
internal resistance.
and internal resistance. Okay, correct. Now coming to the next
Okay, so
question.
that means this is almost like NPSHR and NPSHA. So NPSHR is the EMF, for an analogy of GME.
Yes, and
So required is given by the manufacturer, and
but
available is the voltage that we will measure.
but opposite sign available will be always less in the in this.
Yeah. Available will be less.
Correct. Now coming to this question, Wheatstone bridge concept, what is and why we use it, application of it. We have solved many questions regarding Wheatstone bridge
To
concept.
find the unknown resistance.
Correct. This much only. And if you have to little bit more explain it, then we'll say, sir, it has 4 resistor that is in diamond shape with a voltage source connected across that is in diamond shape. I am just reading it. The Wheatstone bridge is a circuit used for measuring an unknown electrical resistance by comparing it with the known resistance. It consists of 4 resistors arranged in a diamond shape with a voltage source connected across the diagonal of diagonal of a galvanometer connected across the diagonal. I am not going to speak this thing, yeah. Anyhow,
Yeah, in this diamond shape might be a cross question. What do you mean by diamond? Is it series or parallel? Kindly explain. It might be the cross question.
yeah. Diamond
One
shape.
set will be the series, other set will be parallel.
Yeah, two will be in series, two will be in parallel. But I will go and check what are the condition of the four resistor, is how many combination are in series, how many combination are in parallel, or what. But thanks for your cross question. That is,
Yeah, because diamond shape is more of like an art thing. We need to talk about in electrical terms how are they connected.
what do you mean by correct? What do you mean by, I am just writing your cross question mean by this diamond shape, this diamond shape series or
And
parallel.
another one thing, why use a galvanometer in the Wheatstone bridge?
Yeah, galvanometer is to measure the potential difference between, if there is no resistance will flow, potential difference will be zero. When galvanometer is used to measure a potential difference, what was the reason, I am not able to recall it.
So potential difference is going to be voltmeter. So I don't should use that word.
No, the galvanometer is used for to measure the
I
Galvanometer
think
is
galvanometer
small,
measure
is
if
small.
there is a flow of current in which direction. So it will show you like the needle towards right side. That means that is the direction in which current is passing. If it is going left side, that means that is the direction which current is passing. Now, when is the
results in
Wheatstone bridge
0.30.
balanced? That is when there is current passing through that middle line. So we have to keep on, uh, checking our unknown resistance till we get the balanced Wheatstone bridge. So maybe something on those lines. But because potential difference we are measuring, then it could be
Yeah.
See, what is the benefit of this science and logic thing now? Without knowing the answer, we can deduct the answer. Avito says, and I am going to explain. If we get to know the resistance in the unknown resistor, and so what will happen in galvanometer, na? We use a variable resistor also. So we made this resistance and this resistance equal. So if they becomes equal, the potential difference, something will happen, and galvanometer shows a zero deflection. Will show a zero deflection. Something is
yeah.
like that.
Instead of saying that something will happen, we can just say the Wheatstone bridge gets balanced or something,
Yeah, bridge get balance. It will show zero deflection. Okay.
which results in
Mm.
no current passing through the
Uh,
line in the middle
mm,
of the bridge, which means
mm,
that the galvanometer will not show us any deflection. So this is one way of verifying that
mm,
the unknown resistance that we thought about is correct.
mm. Correct. All right. Huh. Now coming to this definition, what is resistor, and resistance, what is inductor, inductance, capacitor, capacitance. Yeah, try fast.
First, as its name suggests, that a resistor is an electric component
Mm.
that resists a flow of electric current in a circuit. Is it?
What is resistor?
Like resistor is like a component resist opposes the flow of electric current.
Correct. And its characteristic is known as resistance.
Yeah.
The okay. Resistance is the property of
Capacitor is
resistor.
a
Now coming to the inductor and capacitor.
capacitor is the capacitance is the like is the capacitor is used to store the electric current,
Store
and
the energy in the electric
the
field.
component which is
Store the energy in the electric
store the
field.
energy, store the electric charge.
No, electric, store the energy in the electric field,
Yeah.
charge per unit area, something like that, energy. remember the capacitor was like this only.
Okay.
Okay, there some polarity will create and the electric field generated from one side to another side. There in that electric field the energy is stored. Okay, you know, yeah, to for switching on this flashlight there is a capacitor in it also, because flashlight requires all of sudden very much energy. Okay, so for that we need capacitor. Capacitor first will store energy, large energy, and will gives all of sudden. That's how flashlight of mobile turn on. Okay, it stores energy, otherwise it will turn on very slow, dim. It requires all of.
Yeah.
Now coming to inductor.
I don't know about the inductor.
Okay, inductor is same analogy,
I don't know about that.
that is it store energy but in magnetic field. Okay,
In the form of a magnetic field.
yeah, in magnetic field.
Okay.
Inductor is the device that stores energy in the magnetic field, in an in a magnetic
Energy.
field. Okay,
Okay.
okay.
The form of
Let me read out the
field.
structure and answer.
Based on self-inductance,
Yes,
right?
Karthik.
Yeah, based on self-inductance, right?
Yeah,
Am I
and
right?
its property is known as inductance, inductor, inductance, resistor,
But
resistance.
it's self-inductance.
Yeah, the next question is the same. Okay, self induction, inductance, mutual
Okay.
inductance. We are going to discuss. Okay. Now before that, I am going to read the
Before that,
definition.
one cross question on this.
Yes. Yes, Evito.
This is not a cross question for the interview, but in the written exams, when I add capacitor, does the phase change by lagging or leading? If I add inductance, does the phase change by lagging and leading, and combination of all of this? Maybe some that, because comes in the MCQ section.
Uh, Current
I
leading,
didn't get the
lagging.
question. Vito.
Regarding
The
that, I don't think so. Current lead lag concept will occur. Lead lag concept will occur when we will be talking about in phase and out of phase. Like in a case of star connection, delta connection, something are in phase, out of phase. There we say which is lagging and which is in which what is lag.
Yeah, that is
Oh
in
no
phase,
no,
out of phase, but in
correct,
terms,
correct.
in one circuit, if I add
Now,
inductance, capacitance,
Yeah,
and
one
resistance,
circuit.
Evito, you are so
That
brilliant.
then there is a phase change.
You are so brilliant. Now I remember, yes, there is a concept in inductor and capacitor which lags and which leads and which lags. I have written it. Thank you, Vito. Thank you so much. Thank you so much. I have written it. See, in resistance, phase, and I was also right. When something is in phase, out phase, then only we talk about thing, this lead or lag thing. Now see how in resistance phase is phase difference is zero. In resistor, phase difference is zero. Correct. So there is no concept of lead and lag. Okay. In inductor, voltage lead. Okay, and inductor, because we know energy stored in magnetic field. In inductor, voltage lead, current lag. In capacitor, current lead, voltage lag. Current lead means
by how much angle, brother?
it's 90 degree plus omega by 2 or plus omega by 2, 90 degree half cycle. Okay,
Omega by 2.
omega omega by 2 angular velocity.
What's omega?
Omega is angular velocity, I think.
Or is it pi by 2 in terms of radians?
Yeah, pi by 2 is the correct word to say. Don't go into the omega
Yeah,
things.
phi is phase angle. Yeah,
Uh,
right.
just a second, guys. Just a second. Don't go anywhere.
No. I'm saying we are around 49 complete in the total questions for the day.
Okay, let's see. I think we have completed. 26 question only. Damn, you are so slow. Anyway, anyway, don't, other questions are one-liner. Uh, Anyone knows about the reason why inductor voltage lag and voltage lead, and why in capacitor current lead?
No idea. You can carry on.
No idea, brother.
Okay,
No idea.
just I am sending one of my friend 10,000 rupees. He is enjoying in Rishikesh. Huh. The next question. The next question is, what is self-inductance?
हाँ ब्रो, ये बता दे.
What is self-inductance?
You didn't complete the answer for the previous question.
What? Okay.
Uh,
So a resistor is a passive electrical component that opposes the flow of current in a circuit and is characterized by its resistance, which is measured in ohms. Inductor. An inductor is also a passive electrical component that stores energy in a magnetic field and is characterized by its inductance, which is measured in henries. Capacitor. A capacitor is a passive electrical component that stores energy in an electric field and is characterized by its capacitance, which is measured in farads. Now the cross question of Avito was, which leads? In inductor its voltage leads, and in capacitor its current leads. In resistor phase difference is 0. Now coming to the, what is self inductance? Okay, any idea, anyone, from the definition, from anything? Rakesh, any guesses what it could be? It would be?
No bro.
Yeah, just I am sending money to him. He is in some chaos. So I am just reading out definition, and
As the inductance is like opposite or something, it may be the same.
it is a property. It is a property of electric circuit.
Okay. Okay.
It is a property of electric circuit whereby a change in current flowing through the circuit, change in current flowing through the circuit induces a voltage in the same circuit. Self inductance. Self inductance. It is self means in the same circuit. Inductance means induction. Induction of what? Induction of voltage. Okay. Just a second.
brother, I have
Yeah.
one doubt. Self induction is possible only for solenoid, or even a single line of wire. Also, self inductance happens.
Solenoid.
This concept only applies to solenoid type of structures only, or a straight wire also this self inductance applies.
No idea, bro. Please write your question and send it on group now. Guys,
Okay.
just give me a 1 minute now. What is a mutual induction? Inductance. Mutual inductance is the property of two electric circuits that are in close proximity each other, whereby a change in one circuit induces the voltage in the other circuit. Okay, like in a case of self inductance, we had a single circuit that in that the induction of voltage in the same circuit. Okay, in a case of
Okay, so
mutual
now
induction.
comes the cross question.
Okay, okay.
Yeah,
What
come on,
is,
continue the answer and then I'll give the cross question.
okay.
Okay, in the meantime, you can just carry on with your money transfer. The cross question is, given that you have just explained mutual induction, give me one real world example of mutual induction.
Mhm.
Transformer.
So transformer is one option, but
Wireless
if you can't think of that, you can,
charging.
yeah, wireless charging is also the second answer. So this will just be, a quick presence of mind check whether you have just mugged up the formula or whether you actually know an example at least. So this makes your previous question also, which you asked, whether a single line of wire can be self-inducting, as an important question, because we need to know at least one example of that.
Okay. And I have one doubt. Have you improved your speaking skills? Because you are good in your speaking. Could you give some tips or how we can improve?
I don't know about tips because for me, English is my first language. Like I just speak English 24/7 for like 20 years plus. So yeah, my Hindi is worse.
Okay, okay. I'm in South India. Here I'm working in a core field. They speak only local language, so I'm more comfortable in my local language only. And my family also they speak local language only, so it's very tough. That's why I'm keep on coming to these gatherings, so we can improve little bit much.
Yeah, that's
I mean,
how.
but your English is not bad right now.
Yeah, it's good. Yeah,
No,
Tamil
brother.
people English
It's
is
understandable.
is not my English is bad.
but I'm not. But I'm not satisfied with this.
Nobody.
I'm not a flow, not in a flow way. I'm just thinking and saying your English are very much flow. This won't attract anyone
Won't attract
Yeah,
anyone.
it'll definitely take some practice.
to the interviewer.
Gyan goes somewhere else only.
Hmm.
It's about 12 o'clock, brother.
Oh, no problem. We are the engineers. We are going to become a sailor. Wait here. Me, Avito, and other guys have held a meeting for 2 a.m. No worries in that. Okay. So you will be benefiting only, na? We are not going doing a gupsup, na? What is the self
Yeah,
inductance? So clear self inductance. Now mutual inductance. Mutual inductance is the property of two electric circuits that are in close proximity to each other, whereby one circuit induces a voltage in other circuit. Unit is Henry. How it induces, don't know. And but what is that?
What is proximity?
What is proximity? Is nearby proximity. And what was the cross question by
Okay.
Avito?
Cross question was, give me a real world example of mutual inductance.
That is the transformer. We have primary winding, secondary winding, and that transformer from the primary winding we have a source that is load in primary winding, voltage in primary winding will get inducted in the secondary winding.
Yeah, so that is one example. Give me one other example that is not given in your, standard GME web preparation.
Mutual inductance. Step down transformer, step up transformer.
No. Transformer is all same. Step down, step up, normals, all same. Apart from transformer, give me one more. You're using it maybe on a daily basis. Not you, but human.
Uh, mutual inductance, mutual inductance, mutual inductance. On.
No. Wireless charging. One coil is in the wireless charging dock, and the other part of the coil is in your phone.
Wireless charging has been released. It is the imaginary.
हाँ तो मतलब it's been there for years now.
Huh? I'm,
हाँ. Some
I'm
smart watches also charge based on that sometimes.
wireless charging. Yeah,
Yeah.
amazing. Yeah, I need to be updated. Yeah. The next question is, what is thermistor and any application of thermistor? What is thermistor? Coming to the answer, thermistor is a resistor that changes.
Temperature sensors.
Yeah, temperature sensor Thermistor is your resistor which resistance changes on the changing of temperature. It is used as a temperature sensing device because when there is a temperature difference, it will sense it and it will show deflection. It is in its deflection in what, yeah?
Yeah, yeah. So basically, we can then measure the value of the resistance and compare it with the chart to find out the ambient temperature that the thermistor was exposed to.
Correct. What is the heating effect of electric current? I will say to interviewer, sir, when electric current flows, it heated up the wire. It caused some heating effect in the wire. That is heating effect of electric current. We use this principle in the case of electric heater. This much. And why this
slightly lacking?
And why this?
Yeah.
Why this? Why this happen? Because when the current flows, there the resistance of the conductor resists the flow. This is due to resistance. Correct. Any cross
Correct,
question?
but more on the why and how.
This is due to the resistance. This is due to the resistance when flow current, the electrical energy converted into heat energy.
Yeah, so you're talking only about resistance. What about size, length of the wire, thickness of the wire? Yes. Everything is dependent.
So in a if we have if we have long wire, then there will be the more resistance. Resistance is basically depends on the length of the wire. It will increase directly proportional and the area of cross section and inversely proportional to the area of cross section. And also and the resistivity of material will be dependent on the temperature. It will be so far, yaar.
Okay. No, because you're just explaining really quick, right? So you'll just be saying directly proportional to length, inversely proportional to this thing, all of that.
All right.
And mainly it is the obstruction of the electrons that they are while passing through the material.
The hindrance in electrons. Okay.
Yeah, hindrance to the flow of current or something like that you can mention.
Yeah, correct. Now coming to the next question, why transmission line carries high voltage?
I think this we have previously already discussed.
Electric power for the over longer distance or something like that.
Yeah. Because to reduce transmission losses in the to reduce the power losses in the transmission line, okay, because it has to carry the over long distance.
Yeah, electric power. Yeah.
The use of high voltage transmission lines allows for the efficient transmission of large amount of power over long distance with minimal energy loss due to the resistance of the transmission lines. The next question was why step up transmission? Why voltage is stepped up for transmission? Because to reduce power losses. Why transmission line carries high voltage? Because the same answer is like that only.
So these are basically the same answer about high voltage in twisted forms.
Yeah, correct. Now the next question: advantage of high voltage power transmission. Power loss reduction, better voltage regulation, and economical. The next advantage of using RMS values of voltage, because RMS values the effective value of voltage and current, and it is used to test the electrical equipment, design and test the electrical equipment. These two things I am going to speak. Okay, let's see what it is. The RMS value of voltage is the effective or average value of the voltage. First, it is the measure of the power of the voltage. Acha, yeah, if we are having the power of the voltage, power source, that is EMF, that the voltage difference, and that source is going to power the load. Okay, So that load, if that load we will calculate in RMS value, average value, that will be the directly proportional to this power voltage, no, power through the voltage, this voltage from the beda gar. It is the
Maybe you
measure.
can just say, as it mentions, it's a mean, so it's going to give you more of an average value, which is more accurate.
Hmm.
Because
It.
let's say, for example, you're talking about the value for a motor.
Hmm.
Initially, the high starting torque might give you a weird value. You might give higher value voltage and power. So if I have RMS value, it will take all of these small spikes in voltage and average it out. So you'll get a more sort of pure value.
Vito, how you mastered in listening something concept and making it like a sensible thing? Just tell me once again.
No, no. So what I'm saying is, as it has the word mean. So
Hmm.
mean means average.
Hmm.
So I'm just thinking that in your circuit there might be some certain cases where there might be a peak in the voltage.
Hmm. Correct.
So there's a peak. I don't want to mention that peak as if that peak is going to be there the full time.
Hmm.
Peak means it is just there for some time and then it is coming back to a normal state.
Hmm.
So our RMS just helps us measure what is the average, not the peaks.
Hmm. Correct. Average, and so that's why it is more nearer to the actual power source that we are
Yeah.
supplying. That's why, na?
Hmm.
Correct.
Exactly.
Okay. It is a convenient way of comparing voltage. It is used in design and testing of electrical component, electrical equipment. Now, the next question is single phase alternating current, three phase alternating current. Okay. Three phase alternating current system, single phase alternating current system. Okay, we have studied about single phase induction motor, three phase induction motor. We are now going to understand what it is. Same concept that a single phase AC system will be using in a single phase induction motor. Let me read out what the definition is. Before that, I want to try because I have read it. Let's see how far I am speaking it right. Sir, single phase AC system uh, operates on a single phase single phase AC source in which the voltage and current will vary sinusoidally with time. Single phase AC system will have a current of frequency typically 50 to 60 hertz. In a case of three phase AC system, we have three phase wires, three phase alternating current waveform, three phase alternating current waveform that are at 120 degrees with each other, and voltage and current varies sinusoidally with time in the, and the frequency is also approx 50 to 60 hertz. Okay, now I'm going to read it
So
out.
one
Yeah, one
one
question.
doubt in this is 120. Are you just mixing it up from induction motor, or is this also
No,
120
no.
properly?
When three phase out of when three phase supply AC system is, whenever there will be three phase, there will be 120 degree. But I am going to remove it because in a case of star and delta, in a case of star only, it makes 120. As far as no, there will be some confusion though, so I am not. I am going to mention it this 120 degree out of phase. Okay, I will be saying that that uses three alternating current waveform. That the waveform, that the graph waveform is the wave, three wave. It will have three wave. Okay, that will vary sinusoidally with time. And three waves, all the three will be out of phase, in phase. It will be the matter of cross question. What will be the phase difference between them? That is the 120 degree. I will be putting up in the cross questions. Okay, now any cross question from Avito? That was because it is very basic. Okay, And single phase AC
Yeah, I
current.
think for now we can pass on because mostly he'll not ask you what is three-phase AC. He might say directly explain the three-phase induction motor.
Yeah, correct. Okay, so a single phase AC system used for residential purpose, three phase AC system used for commercial purpose. Now coming to the definition, a single phase AC system is a system that uses single alternating current waveform to transmit power. The voltage and current waveforms vary sinusoidally with time, and frequency of the waveform is typically 50 or 60 hertz, and it is used for residential purpose mostly. Three-phase AC system that uses three alternating current waveforms uh, to transmit power. Voltage and current vary sinusoidally with time, and frequency is 50 or 60, used for commercial purpose. Any cross question? No. But see, in a case of three phase, it is written that are 120-degree out of phase with each other. Yes, he might ask what is waveform. So I will say, sir, waveform is the shape of the wave that is being generated, wave that is sinusoidal wave, that we are calling waveform. That will make sense to him.
Yeah, so you can just say that on the horizontal axis we have time, and on the vertical axis we will be plotting the polarity. So is it currently on plus one side or minus one side or zero? At any given point of time, we'll be plotting for all three of the phases, or in the three phase.
So the form, I will say in this case, sine function sinusoidal waveform we are getting in alternating current is the shape of the wave or shape of the curve that is generated in the voltage current with the time graph, something like this only. Basic idea is not, we are just freshers and not an electrical engineer. Okay, now coming to the concept of earthing, concept of grounding. Why we do earthing or grounding? Yes.
For the safety purpose.
Yes, correct, for the safety purpose. But what is the concept behind it? What actually we do?
We just we have the metal piece or something. We connect the system with the metal piece in the earth.
You are far more correct. It will be understandable. I will be putting this shape in an electrical concept. It is the process of connecting a non-current carrying wire to the ground or earth. Okay, it provides a least resistance path in a case of fault or current, or in a case of current fault, in a case of any fault in the current. So current will prefer to go in that least path direction. Okay, least resistance path current will prefer to go in that least resistant path. Okay, that's how you will be saving all the extra charges or the current that can damage possibly the person or the equipment will go in the earth. Making sense? Now I am going to read the now I am going to read the what I have written. It is the process of connecting. You just said the metal wire, na? Yeah, no problem. You didn't say that it will carry current. No, it is the process of connecting the non-carrying current parts of an electrical system to the ground on the earth. It is conductor, na? Only it is conductor, na? Yes, non-carrying conductor I should have written. Is minor. It is the process of connecting the non-current carrying conductor of an electrical system to the ground or earth. The earthing system provides a path of least resistance for a fault current, which helps to prevent electrical fires, equipment damage, as well as protect people from getting electric shock. Clear, guys? Okay. Any cross question? No. Okay. Concept of neutral wire. Yes. Why we use neutral wire? We from the childhood we have heard of neutral wire. Neutral wire. What is neutral wire? It is same as the earthing wire.
Kind of like it is also used for the safety purpose to prevent the electrical shocks and protect the equipments from the short circuits.
I think mainly we need to say that we need some,
Avito,
the meter to complete.
your voice is so much lagging. Okay,
Like,
Jack, take care.
go.
Take care. Always nice to have you. Yeah, sometime.
What I'm saying is for neutral wire, earthing wire, you can't say the same answer of security and no shock.
The
Your
correct.
voice is still marathons.
Mic test, mic test.
Yes.
Done. Second.
Wait, actually, let me just get another headset. I think these headphones are messed up or some shit is going on.
Anyway. Yes. So what was okay? So concept of neutral wire. Let Avisto set up his mic. Till then, I am explaining what is concept of neutral wire. Neutral wire in a electrical circuit is to there are two work it does. First, it provides a return path. The second, it complete the circuit. What is the
It provides
consequence?
real path.
Yeah, it provides the return path. Okay, for
Okay.
and it complete the circuit. All right. Now coming to this, what is the consequence of this? It consequence of this is that the stability maintain the stable electrical system. Actually, what happens if there is some imbalance in voltage or current in the hot wire? There is two wire, hot wire and neutral wire. That will be take care
Yes.
of neutral wire. Okay, that will pass on. So the neutral wire in a conductor that provides a return path for a current in an electrical circuit and helps maintaining a stable electric system. It is the first point to say. Further, we can add if we'll say anything that it completes the circuit when there is a how it is stabilizing the electrical system. Then we'll say, sir, if there is some imbalance in hot wire, then it will take care of neutral wire. From the neutral wire, it will goes again to the source. From source to load, the current.
Mic check, mic check.
Yes.
Yeah, we know.
Yeah, we do.
Okay, yeah. So exactly. So as you said, what I was saying was that we cannot say the same part that neutral wire is also part of safety and all of that. Just that would be for earthing wire.
Correct.
So as you mentioned, it will be
maintain
to complete the circuit. Yeah.
Complete the circuit and maintaining a stable electrical system. Not do not mix with this. Okay.
Okay, bro.
All right. Neutral power to complete the circuit, to provide a return path, to balance the circuit. All right. Now coming to this question, very common question: what is synchronous motor and non-synchronous motor? Any idea? Synchronous, the word itself defines its. Try, Rakesh, try.
Which runs at synchronous motor for motor which runs at the synchronous speed, and the synchronous speed is like 120 p by f. Formula for
120
that
into
is
F by P.
uh,
Anyway,
I was always wrong in this.
No. Synchronous motor is a type of
Non-synchronous is the three-phase na?
well, see one thing to remember. Synchronous motor will have a synchronous motor is a type of AC motor will have constant speed. Okay, and non-synchronous will have
Okay.
does not have constant speed. That's why in non-synchronous motor we need gearbox to control its speed. Okay. Now coming to the whole definition.
Okay.
The synchronous motor, a synchronous motor is a type of alternating current motor, AC motor, that operates at constant speed that is synchronized with the frequency of the AC power supply. Now going to the formula. Synchronous speed ns equal to 120 into f by p. P is constant. Okay. Here we have
He is called.
ns is synchronous speed. Here I have frequency. Frequency is what? Frequency of the power supply. So frequency of the power supply uh, and synchronous speed. This synchronous speed is constant. So it will synchronize means it will somehow not exact value, but it will synchronize means if frequency will increase in the same proportionality, its speed will synchronous speed will be also increasing. Am I making sense, Evito? Yes, correct.
Yeah, so you mentioned in the same proportionality, but in synchronous it is exactly the same. So you can just say the same speed will be there by the
No.
rotation.
Orange and apple can be how can be same exact well, like orange and apple how can be same, like orange is synchronous speed and apple is frequency, so it can synchronize. Okay, if we are four oranges, then we can have four apples. That what I meant. Synchronize with
Okay,
the
you can go with that.
okay. Now coming to the non-synchronous motor. Yeah, these were two liner answer, constant speed and synchronized with the AC power supply. But the headache of that thing not knowing have had become a very nightmare for my so many nights. Now I am feeling relaxed. Okay, today only. A non-synchronous motor is an AC motor that does not operate at a constant speed and may require additional components such as gearbox to control its speed. Making sense? Now, coming to the next question, what is power factor? Any idea? Karthik, why are you silent? Yes, Rakesh, go ahead.
Power factor means the ratio of active power or to the total power. The how much efficiently the power is used.
Yeah, it tells about the efficiency only, but the formula is not correct. Karthik?
Yeah, actually, in a household, the power factor would be 0.9 something. Not
Active
Yeah.
power
sure.
or current power something like that.
No, you just
Is it yeah?
you just
It
reverse
is
the formula, Rakesh. It is real power upon apparent power. Okay, apparent power.
Okay.
Okay, so power factor is a
Like
measure
apparent
of
power is
the
like the total power, na?
apparent power is that is can be called as the reactive power, like a total. Yeah, the reactive power which are giving we are giving as an input from the generator. That's why power rating was in kilowatt kilovolt ampere na.
Uh,
Anyways,
so I don't know much about that.
leave that, just remember that just you said power factor is a measure of the efficiency of an AC electrical system. Alternating electrical system, it is an efficiency. Power factor is a efficiency for alternating electrical system, and its formula is given by the real power in watt upon, it is a ratio of real power upon apparent power in watts. Okay, if the power factor is 1, then we'll consider it is running, the system is running with the maximum efficiency. Okay, and if power is less than 1, power factor is less than 1, it will it indicates the system is less efficient due to some reactive losses, reactive power loss. Okay, reactive power loss can be internal resistance and all. Okay, eddy losses, shock losses. Correct, guys? Now the next question is
actually I haven't seen a
Yeah.
power factor that much deep, but I have seen in real life that in industries they use power factor equipments where they set some specified power factor, and the government officials also come and check whether they maintaining the specified limit, because you said no, maintaining exact one is an offense in India. So the government officials also come and check whether they are maintaining the same limits, and there are certain agencies also working for this. In big industries, it's a big equipments are there for maintaining the constant power factors. They use this servo capacitors, but I don't know technically. I saw in the industries, that's why I'm sharing.
Yeah.
I don't know much.
Yes, some more clarity on what will happen if I keep running my machinery at power factor of 1.
One. No. How can be power factor 1? It is just ideal
No,
situation.
no, I'm just saying, what happens if I have a higher power factor? Like, why is government wanting me to reduce my power factor, or does he want me to increase my power factor?
No, they are asking to reduce, not reducing. It keeps on fluctuating. We should have a power factor nearby zero point 0.9, and if we have the power factor constant, we have the more efficient. But in real life, the power factor won't constant. It keep on fluctuating. In household, we don't take that much effect for having the same power factors, because here we use very little amount of power, but in industries it worth lakhs, so they give more importance to these things. And you are saying we need higher
Okay.
power factors. Yes, for a certain limit only. If we try to keep on increasing, then we would be in jail.
Yeah, don't want to know that. We would be in jail.
Yeah,
That is terrible. I have heard of.
that's a serious issue.
I okay, all right. Thanks for giving acknowledgement.
One thing on power factor, the formula says watts upon the volts ampere, not
Yeah,
both watts.
volt ampere. यार by mistake I said what na volt ampere. Yeah. Just I will mug up. I don't want to go in this. In a electrical package, sir has told about the power factor thing, but yeah, I will complete it after my interview. I have heard of servo motor, but not servo capacitor. Thank you. I will be searching for this, what it is, and in the next meeting we will discuss about that. Then coming to the next question, that is very important question. Common question. What is electrochemical corrosion or galvanic corrosion? It is also called galvanic corrosion. Try. Anyone? Karthik Raja?
If two similar metals of electrochemical series nearby, then corrosion occurs. It's only,
Yeah.
little bit.
Yeah. Overall concept. No problem. When two dissimilar
And
metals
it presents in the
presence in the
occurs in the presence of moisture.
connect with each other by the presence of electrolyte, okay, or salt water, by the electrolyte, there will be the electrochemical corrosion. There is a chances of deterioration of the materials, okay, metals, okay. So from the anode it will be oxidation, that is the more reactive material, and at the edge of less reactive material it will be the cathode, gain of reduction, gain of electron, so anode will deteriorate faster. This is how it is. Now I am coming to the definition. Electrochemical corrosion is a process that occurs when two dissimilar metals are in contact with each other in the presence of an electrolyte. The more reactive metal or anode undergoes oxidation, that is loss of electron, while the less reactive metal will go in the reduction, that is gain of electron. This can result in the deterioration of metals. Avito, any cross question?
Okay, so my question can be that more reactive one is going to be the one which is going to get the corrosion or get oxidized. So will this have lower or higher value of the reducing power in the
Reducing power? Like, didn't got your question.
electrochemical cell? We have that value, right? The different values
Hmm.
of EMF or whatever
Hmm.
for each terminal.
Hmm.
I'm not sure if it's called EMF whatever, but you understand, right? Like iron has its own value, copper has its own value, zinc has its own value.
Yes, yes. It has
Which is
reactivity
getting
series. Reactivity
oxidized.
series. Hmm.
Yeah. In the
Hmm.
reactivity series,
Hmm.
mentioned that we have the more producing. I mean, we have one of them which is at the anode, which is getting oxidized. So
Hmm.
this more reactive anode has a higher reactivity or lower reactivity value.
Higher reactivity value. It has more electric potential. It has more electric potential. Okay. It has more electric potential. It will oxidize. The loss of electron will
Okay.
happen. It will become thinner. Okay. Okay. Now the next question
Okay.
is, what is the critical speed of machine? It is an interview question that has been asked. What is the critical speed of machine? Why it is called critical? Any idea?
Okay, let me explain. Critical speed of the machine is the rotational speed at which the machine becomes unstable. Like it is the uh, higher speed
Not
at
very much
which
highest. Yeah.
it experience some
Yeah.
it experience some vibrations and
No, you
You
see,
are.
in vibration topics, there is something called whirling of shafts.
Hmm.
There they have a resonance. If the frequency of the rotating shaft is equal to the resonance speed, then we have this critical. That's called the critical speed. At that time, the metal can easily break or it causes a serious damage. So in ships and everywhere, we won't like to reach a critical speed.
Yeah. Critical speed is not a highest speed. Okay. Make this. Yes. You are right, Rakesh, that it can cause damage. It will. Okay. What happens is actually, Karthik Raja was very much right that when the rotational speed of the motor, when the rotational speed at when the let me read, I am also not making sense. I have to read it out. The critical speed of the of a machine is the rotational speed. Is the rotational speed. Listen, is the rotational
yeah.
speed at which the frequency of natural vibration of the machine matches with the frequency of the applied force, causing resonance and potentially damaging the machine. Now coming to the explanation. Suppose critical machine. Okay, suppose rotational speed is n and frequency of the applied force, that is the frequency of the supply voltage, is f, n and f. Okay, so it is the rotational speed at which this f will match the natural vibration, okay, of the machine, natural vibration of the machine. There will be resonance occur. You must have heard of this phenomena that the when army parades on, when a contingent parades on bridge, there is chances of collapsing a bridge. Why? The frequency, how they parades, if matches with the frequency vibration of the bridge, it can collapse. It has scientific approximation. You have must have heard of in this childhood.
Yeah, it's a very standard example.
Yes, sir. So this is the analogy is same, in which it is saying when the speed, the critical speed of the machine is the speed of the rotational speed of at rotational speed at which the frequency of the natural vibration matches with the frequency of the supply voltage or frequency of the supply applied force, causing resonance and potentially damage the machine. Okay, now until now we have completed 40 question, 20 question only more. Be with guys. I am going to cover on 41 question. That is, what is it is? Hi Abito, you got network problem, na?
Not network problem. I'm just not on my system, so I don't have my headset and laptop, all of that stuff.
All right. So the next question is, if the ceiling fan is rotating slowly, what will you check there? Common sense question.
Resistor.
Capacitor, condenser.
Yeah.
Regulator.
What is regulator in fan?
No, he's talking about the controller, fan controller, right?
Yeah, sorry.
Maybe that is stuck on speed number 1.
And anything if the ceiling fan.
I would say the current would be single phase.
No, let me check the what is the probable answer. If ceiling fan is rotating slow, there are several things you can check. The fan blade,
Yeah.
like make sure they are clean or not obstructed by dust or debris. The motor, check if the motor is working properly and not overheating, because if it will overheat, the electric energy will be converting into the heat energy mostly, which should be being transferred to rotate the fan. The next is the
Yeah.
capacitor. The capacitor is the component that helps the motor start and run. Check it if it is the main answer is the capacitor only. And the third, the last is voltage. Make sure the voltage supply is adequate for the fan. If the voltage supply is not adequate, then capacitor will also not help in rotating it fast. Is it? Isn't? Okay.
Yeah, maybe we can also mention bearing, because if the bearing is spoiled, then more friction.
Yes, in spite of rotating, internal components will rotate faster, but the fan blade will not catch up that speed, and in result, it will slow because of the bad bearing, because of the weird and teared bearing. Okay. Now the next question
Yeah.
is ceiling fan components and working principle. Ceiling fan components, we are having fan blades, motor,
Yeah.
capacitor, bearings,
Connecting wires, capacitors,
pipes,
rotor, stator,
rod,
winding.
rotor, stator, yes, windings, and the principle is fluid dynamic principle. It as it rotates, the flow.
Fleming's left hand पे रहता है ना कुछ
Yeah, and
ऐसा.
another one important thing is in ceiling fans and in mixie, these things they use a universal motor. You know about that?
Hmm.
Universal motor. You know about that?
No.
Uh, Actually, is universal motor is it can run in AC and DC. Both they can.
Universal motor. All right.
Yeah.
Let me read out the answer for that. Ceiling fan component typically include motor. The motor is responsible for turning the blades. The blade create air movement. Capacitor. The capacitor provides a boost of power to the motor when the fan is turned on. Okay. Switch control the fan speed and direction. Housing protects the motor and other component. And the working principle of the ceiling fan is based on the principle of fluid dynamics. The spinning blades creates an air flow that moves air around the room, providing a cooling effect. All right. Now coming to the next question. Why we asked to wear slipper while handling electrical appliances?
So I think this is pretty straightforward, right? We
Hmm.
don't want to become the shortest path between that electrical object and the ground, which is why we put a insulator between us.
Yeah, correct, correct. It is
It have high
very good answer.
resistance,
Okay,
so current won't
let
flow.
me write it. Let me write it. What we don't want
No,
to
no,
be.
it doesn't have high resistance. It has low conductivity, is what we can say,
No, no.
Okay.
So
because you're
least
talking
no, no, no.
a
See, see,
insulator.
see, see, see. What is the problem is that we are not a least resistance path. Okay, we will give a high
No, no, I'm
resistance.
saying we should not be.
We should not. No, no. We so if we will be also now we will be not a least resistant path. Or there is two thing now. The
See. Example is, what if earthing has failed?
hmm,
You don't know about this because the earthing is just buried in the ground. Let's say some rat came, ate earthing, your earthing has failed. Now, when you go and touch the, let's say, microwave, for example,
hmm.
or without the rubber slippers or anything, when you touch microwave, your legs are touching the ground. You are the shortest link between the external shell of the microwave and the ground. So the current will flow you and you will get the electric shock.
Correct. Yeah,
So
correct,
to avoid
correct.
this, we put a rubber mat under our feet.
Hmm. Making sense. The next question is what is AVR? If Jack would have here, he would have answered this. AVR. AVR is automatic voltage regulator. It is a device that regulates
Regulator.
the voltage output of a generator to maintain a stable and constant voltage level. Okay. AVR is used in situation where constant voltage supply is essential for proper operation of electronic equipment. So there was one doubt in the starting of meeting with Jack that why he was forcing asking that the diode controls the voltage fluctuation or diode or something like that only. So in a case of AC generator, DC generator, we have this AVR to maintain a constant voltage. Okay, so that
Yeah,
I
in our household also we have this AVR.
voltage
Not exactly like.
that stabilizer is the same voltage regulator. We had stabilizers for earlier cases for earlier like in earlier days for refrigerator.
No. There is a stabilizer for a whole house. We have a big thing, and there we have a one pinion rack and pinion arrangement where it slide on based on the it tries to make 230 volts. If keeps
that
on fluctuating, it will
that you're talking
make.
about MCB.
No. It's a big box. Because in our area the voltage fluctuation is very high,
Hmm.
so we bought a new one and using.
Okay,
Okay.
please tell like what that is automatic voltage regulator only.
Or send some photo of that on the
Yeah,
WhatsApp group also.
yeah, sure.
Yeah,
It's a
okay.
mechanical related, not a. And nowadays they I somewhat hear they using relays also
Okay,
to regulate voltage, but I know not that much deep about that.
all right, correct. Huh. Now we are going to discuss after what is thermocouple and how thermocouple is connect. What is thermocouple only? How thermocouple is connect? Don't take- What is thermocouple?
I don't know much about it, but basically it is used for the measurement of temperature, like electrical thermometer.
Its name in the name it is
Yeah,
therm.
when
It is it
similar metals
in the name as it mentioned
Used
thermo
to
means temperature. Something is related with
yeah,
temperature.
temperature.
Yeah, when two dissimilar metals are connected in a series, an EMF is generated, which is equal to the temperature. That's it's work based on Seebeck effect. Seebeck effect.
Seebeck
Am I
effect,
right?
yes, a Peltier effect, Seebeck effect. Okay. So Seebeck effect is generally when there whenever there will be temperature difference, then in the thermocouple is that device when there will be temperature difference and voltage is induced, or voltage is induced,
Yeah,
and
EMF
that, huh?
EMF is induced.
EMF is voltage only, no? Yeah, EMF is
Yeah,
an.
yeah,
Let's see what it is.
yeah. Okay, okay.
A thermocouple is a temperature sensing device that consists of two different metals connected at one end. When the junction of the two metals are exposed to different temperature, a voltage is generated. Voltage and EMF is same thing, na? Voltage is generated. But better to say voltage here, okay? Which is proportional to the temperature difference. Proportional, not equal. You just said equal. Proportional to the air
Yeah,
thermocouple.
yeah, yeah. Because why I'm saying this EMF is I referred PK notebook. That's why I'm saying.
Okay, all right. No problem. That is also correct.
Yeah.
Thermocouple is typically connected to a meter or controller, which measure the voltage and calculate the temperature. Oh, it can do the same thing, na? By measuring
Yeah,
voltage,
like the
it
power.
can calculate temperature. If there is temperature difference, it can calculate. It can produce voltage. Same. Okay. Now coming to the next question, difference between star connection and delta connection. Any idea about this? Anyone? No worries.
Yeah, this
Okay.
delta connection. I'm not sure. This delta connection is mostly used in generator. Am I right?
Let's see. Star and delta connection are two different methods of connecting three-phase AC motor to power source. For three-phase AC supply, both the connection is there are both the connection will be for three-phase AC only. Okay. While the main difference between star and delta connection are number of connection. A star connection has a three component, that is the neutral and the three phases. Okay, three phases means three wires, for three hot wires for that three phases. Okay, and along with the neutral in a star connection. While in a delta connection, only three phases. There will be no neutral. First thing to
Yeah.
remember. Okay. In a case of star connection, we will have three phase. First, both are for three phase connection. But in a case of star connection, we will have three phase along with one neutral phase. But in a delta connection, we will have three phase, non neutral phase. Okay.
Okay.
Makes sense.
Now making sense. Number of connection. This was number of connection. Now coming to voltage. The voltage of star connection is lower than the voltage of delta connection for the same power rating. For the same power rating means for the same input, for the same input supply, yeah, for the same supplies of voltage, yes, for the same input. Okay, for the same input, the voltage of star connection will be lower. Okay, why it is lower don't know, but delta connection will be have higher voltage, and delta connection using only three wires. Okay, now the coming to the next, the current in the star connection is higher than the current in the delta connection for the same power rating. See guys, in a case of star connection, we are having a voltage low, current high, voltage low, current high. Star, voltage low, current high. And in case of delta, voltage high, current low.
High current.
Voltage high, current
Yeah.
low. Okay. Yeah, some code, yeah, some trick we can remember this.
So basically, power is equal to VI. So if one is becoming less, the other is becoming more. Something like that, right?
Yeah, star we have.
Power is constant.
Yeah, yes, power is constant. Correct. Power is constant, but we have to remember na to which has lower voltage. Star has lower voltage. So star and voltage. Star voltage lower. Delta is higher voltage. Delta higher. Delta. Some keywords.
Wait, delta has higher voltage, right?
Uh-huh. Delta has higher voltage
Hmm.
and lower current.
415.
Delta has higher. Delta higher. Yeah, Dell. Some player name was Dell, na? Dell Steen. Yeah, Dell Steen. Ball. Hires ball. Dell Steen play with a. Dell Steen rises the ball very higher than Michael Stark. Okay. Delta connection will have voltage higher voltage and lower connection lower current, uh, vice versa. Delta connection will have,
Also in this, some have less starting torque.
hmm?
I'm little bit confused which will come, star or delta, but I know both have some differences. Starting torque also somewhere it have less, and some this star or delta are used in a generator and this motor. I'm not sure, but there's a difference with this.
We'll discuss about in detail, but we are just going through the superficial, just making ourselves little bit into just relationship started with this. Okay, we'll carry on the relationship.
Actually, I am just sitting without a preparation. That's why I'm
No problem. No
saying
problem.
everything with
See,
assumptions.
say something is better than nothing. Okay, you are already a far more than the other 140 people. Okay, you already know.
Okay.
These are the nothing question can cross this question, this sets of question. If you will have a little idea also about any of the thing, just you have read here, synchronous motor or why AC can't be stored. If you say in front of interviewer with your mind, presence of mind, it will help you only. Okay, now coming to the last application of star connection and the delta connection. Star connection are commonly used for low power motor because low star connection is a low voltage connection. Voltage of the star connection is low, while delta connection are used for high power motor because delta connection has high voltage, okay, and low current. I will be sending the notes, don't worry. Now coming to the
Okay.
next question. Star
So that means high power. That means in case my motor has high starting torque, I have to give it a delta connection by deduction.
once again.
So as you mentioned,
Hmm,
star has lower voltage,
hmm,
and oh, but actually I'm talking about voltage, but that doesn't give me much about power.
hmm,
Yeah.
I was thinking that maybe if the voltage is higher,
hmm.
does it make a difference in starting, or is it the current that is more important? We can just figure this out later, otherwise.
Okay, later. Okay. All right. Let me see for the next question. I think I am Rakesh. We have added extra question na, for that. Mm. Where was the sets of question? Oh, yeah.
Okay, let me
Yes.
read it
Hmm.
again.
Star connection, delta connection. Then
48 you have to do now.
uh, now coming to the difference between fuse and circuit. Fuse and circuit.
Circuit breaker.
Fuse and circuit breaker. Yes. What is the difference between fuse and circuit breaker?
So I think one of the definitely biggest things will be reusability. Fuse is a one-shot thing. You have to
Yeah.
throw the fuse out and get a new fuse. But
Hmm.
circuit breaker will just drop the circuit breaker. I can put it back up with my finger.
Hmm. Makes sense.
So circuit
And
breaker will
I
be
think
working.
the circuit breaker works based on a bimetallic strip. Is it right? Concept.
Yeah,
Two
By
similar metals on a heating just bends. I just saw YouTube video and I'm just remembering. Am I right?
let's see what was the question. And the next question is, what is the difference between wattmeter and voltmeter? Any idea?
Wattmeter is to find the power and voltmeter is to find the voltage. Is it right?
Yeah, sounding right. Let's see. And next question is, I'm sorry guys, I'm lacking.
But the
Hmm.
capacitor in electrical circuit.
The next question is, what is the purpose of capacitor in electrical circuit? Tell.
It's like a tank. It just stores the energy and release whenever needed.
Hmm. Correct, correct, correct. And now, what is the next question is, what is the difference between series circuit and parallel circuit?
so I think this is where we have to talk about whether voltage or current will be divided
Hmm.
and what will remain untouched.
In series, current is same. In parallel, voltage is same. Correct,
Same,
guys?
because we are talking about
Hmm.
point A, point B.
Hmm. We have already discussed the.
And maybe you can even talk about how they are connected. So in series, you will have a
Hmm.
terminal to terminal connection. So that means the ending of the first component
Hmm.
will be connected to the starting of the second component. But
Hmm.
in parallel, the starting of both component A and component B will be connected at one node, and the ending of component A and B will be connected at the node.
Didn't get you, like what? I have
No, no,
very
no. I'm
bad
saying you
skill.
can also mention how they are connected. So in series, you'll have component A,
Hmm.
and whatever is the ending of component A,
Hmm.
that is where we will start component B.
Hmm. Yes, yes, correct.
And
Hmm.
in parallel, the starting of A and B will be together,
Hmm.
and ending of A will be together at one point.
Correct. Now the next question is, let's read the definition. Before that, the main difference between a fuse and a circuit breaker is that the fuse is one time, correct, non-resettable device that protects the circuit by melting when the current exceeds its rating, while a circuit breaker is reusable device that trips and opens the circuit when the current exceeds a certain level, okay, but can be reset to closed and once the fault is clear. A voltmeter measures the voltage difference between 2 points in an electrical circuit, while a wattmeter measures the power consumed by the circuit. You are right. It's a you told about the power, but it's a power consumption by the circuit. In other words, a voltmeter measures voltage, while a wattmeter measures voltage and current simultaneously. Because it is measuring power, and power is V into I, isn't?
Is into VI.
Hmm. Uh, how how does solenoid valve work?
Yeah, based on Faraday's law of induction, there's a solenoid valve as current flows. Higher magnetic field creates and it's pushes the valve open. That's spring and solenoid connection available. As the solenoid valve get energized, the this what do you say? The metal will rise up, so the valve opens.
Hmm.
So Gyan, just one correction over here. Would it be Faraday's law of induction? Because this is more of electromagnetism.
Let's see what is. A solenoid valve is an electromechanical device. Electromechanical device that uses solenoid to control the flow of a fluid or a gas through a pipe or a duct. Flow of a fluid or a gas through a pipe or a duct. When an electric current is applied to the solenoid, it generates a magnetic field that attracts the plunger or armature which opens or closure. When electric current is applying, it is generating a magnetic field. Is
Can you
elect
explain what is?
is electromagnetism, not electromagnetic induction.
So now comes the cross question.
Hmm. What is electromagnetism?
Example in real life. No. Example of this in real life. Of a solenoid valve.
We have solenoid
I'll not say solenoid valve, but solenoid is the main uh, type of
on board chip.
actuator in this product
In
at your house. Let's take in your house.
but I can give a
Mainly in heaters we use, and I have seen in LED bulbs also, but that's inductor. I'm sorry, mainly in heaters.
Okay, so one example of this is your house doorbell.
correct, yeah.
Yeah, but
So what
I
happens
haven't opened
in
that.
your doorbell? Yeah,
Okay.
what happens in your doorbell is I'll just show you like this. Wait, how the hell do I keep this phone?
Okay.
Okay, so imagine this is a metal plate.
Hmm.
Okay.
Okay,
Hmm.
this finger is a metal rod,
Okay.
So you are
and
not
my
looking,
hand
you
is
are
like a
not
coil.
seeing, your camera is not on. If you trying to,
What? It's not. Is it on now?
yeah, is it on? It is on.
Okay. So
Video is
this hand,
paused.
imagine this flat surface.
Video is paused due to the problem.
Pause.
Yeah,
No,
due
for
to
me,
network.
okay, Gyan.
Huh? Yes.
तेरे नेटवर्क में इशू हो गया
Okay, okay,
For
okay.
me, it's, no problem.
Okay, you can
Okay,
carry on,
yeah.
Avito.
But just imagine,
Hmm.
yeah. So imagine this is a flat surface on your left hand.
Hmm.
Yeah.
Imagine your left hand is a fist and you have a flat surface. So this is
Okay.
going to be a metal plate or a
Okay.
metal, ringing sound metal thing. And here I have a
Okay.
which is a metal rod. And this hand over here is like a coil. So when
Okay.
power is coming to the coil, it becomes an electromagnet and it pulls this finger inside because it's a rod. So the magnet will suck the rod, so it pulls this inside, and the bell is not rung. So when you leave a switch of the bell, the magnet stops and there's a spring. So this gets power, goes and hits the metal plate. That's how
Oh, okay.
the
Okay.
doorbell works.
Understood. Understood. That old mechanical style calling bells are working on this principle.
Yeah, like ting ting, those ting tong, those type of bells.
Okay. Okay.
Correct. So I had
So it will
also
be a electromagnetism.
Okay. Okay.
electromagnetism. See, in next session, I will be discussing about the difference between electromagnetism and electromagnetic induction, because today only I got to know what is the difference, and it is like the basic definition is electromagnetism just tell about the interaction between magnetic field and electric field, and everywhere it is not necessary that it is electromagnetic induction that is applying. Electromagnetic induction
Yeah.
is applying where it is the where it is generating the EMF, okay, or
Hmm.
voltage.
Okay.
Here in a case of it is generating a magnetic field that is sucking, that is the for closing and
Pulling that metal rod.
yeah, pulling that matter. You know the sucking word from where it
So
is.
basically, we can simply say
Hmm.
to understand the funda,
Hmm.
if I am getting EMF as the output,
Hmm.
it is going to be induction. But if I am supplying the EMF or the voltage to get the work done of the creating the magnetism, then I'm going to be making a electromagnet, which is called electromagnetism.
Okay,
Yeah,
okay.
electromagnet in a remember in a case of single phase AC, a single phase induction motor or three phase induction motor, what is producing the torque in the rotor? It is the magnetic field generating the torque in the rotor. So that is not that was not based on electromagnetic induction. That was based on electromagnetism. Okay. All
Okay,
right,
okay.
all right. Now coming to the question I have asked, the let's see what is the answer is. I have asked about. I have also asked about the what is the role of capacitor in an electrical circuit. So you told about it acts like a tank that stores energy
Yeah.
and provided it. Okay. Let's see what it is. A capacitor is a passive electronic component that stores electrical energy in an electrical field between two conducting plates. In an electrical circuit, a capacitor can be used to block DC current, filter out noise, smooth voltage fluctuation, and store energy. Filter out noise, same concept. Yeah, it is your concept was too right. I am only speaking your, will be speaking your concept. Okay. Anyway. Now coming to the
So in the end, the capacitor is going to act like a flywheel. Best analogy. Whenever there's lack of power, it will supply. If there's excess power, it will suck up.
hmm, making sense. What is the difference between a synchronous motor and induction motor? Hmm. A synchronous motor operates at a fixed speed and is synchronized with the frequency of the power supply. We know. While an induction motor operates at a slightly lower speed and it is asynchronous with the power supply. Okay. It has not asked
Yeah.
that single phase induction motor, three phase induction motor, but the thing is that induction motor does not rotate with the constant speed. Okay. Motors operates do not operate at fixed speed. Okay. Synchronous motors are used in applications that is required precise speed control such as clocks, record players, and generators, while induction motors are used in most industrial areas and domestic applications such as fans, pumps, and washing machine. Okay. Now solenoid valve. What is solenoid valve? Solenoid valve is
Then
uh,
I have one doubt.
yes, yes,
Yeah,
yes.
in this synchronous motor and this synchronous generators, will they use any systems like auxiliary motor or any auxiliary things to work
Start. No,
this
no,
thing?
no, no, no. There is no such thing. A motor and generator, they use the same concept of electromagnetic induction, but in motor, electrical energy convert into mechanical energy. In generator, mechanical energy convert into electrical energy. That's it.
Because I saw in some YouTube videos, synchronous concept is much clear. That's why I just clarified how
Yeah, we can
this produce.
if you provide the source that it requires some auxiliary winding or auxiliary component to start for starting mechanism, because here we have just uh, differentiated the synchronous motor and induction motor, and we have already studied about the induction motor required auxiliary component for starting mechanism.
Yeah, we know well induction motor, but this synchronous motor construction is much complicated.
एनीवे यार वी आर मैकेनिकल इंजीनियर 32 आप देख लेंगे अभी तो
Yeah.
लेट 32 आप देख लेंगे उसको ठीक है नाउ कमिंग टू द डेफिनेशन ऑफ द solenoid valve let me revise it again. Okay, a solenoid valve is an electromechanical device that uses solenoid to control the flow of a fluid or gas through a pipe or duct. When an electric current is applied to the solenoid, it generates magnetic field that attracts a plunger or armature with which open or closes the valve. Making sense? Now coming to the next question, what is relay and what are the some common use of relay in mechanical system? Any idea? What is relay?
No, bro.
Okay,
Relay is like a switch.
correct, correct. First thing, you are now carry on.
Can we say it helps us to make a transition between electronics and the electrical circuit. So all of the small IC circuits, everything will be in the electronics low power, and then the relay will get the signal in electronic slight low voltage, and it will open up a switch for high voltage.
Let's see what will be what it will be. Guys, my project was automatic motor bike stand. So there we used relay, and what was the function of relay? There was we used bike stand, and the we on the edge of the stand we just used a gear, sorry, a DC motor with gear to control its to slow its speed. Okay, to gear. So in a case of we use this in bike, so what has to bike to do? It is automatically getting up when bike starts and automatically getting down. So if it is getting up and getting down, so at this time if it is getting up and it has to reverse its direction to get it down, direction of the DC motor, that is controlled by the that was controlled by the relay switch. What our team leader had explained us about that, what was the function of relay switch. Now come to the point. I have also not very much idea but little bit idea about that. Let's see what it is. A relay is an electrically operated switch that uses a small current to control the larger current. Relays are commonly used in mechanical system to control motors, pump and other device. They can be used to switch high voltage current with a low voltage signal to isolate the control circuit from the load circuit and to provide the electrical isolation between circuit. Not a very good definition, but it is controlling
But
purpose.
making sense.
Making sense.
So basically, what it's saying is you want to keep all of your important logic. So let's say, for example, you have these automatic sprinkler systems. So
Mm,
exactly at 6 o'clock,
mm,
the sprinkler system has to pumping the water.
mm,
So in that case, I don't want to keep the high voltage current passing on to all of my important
mm,
microcontrollers and microprocessor. So all of the microcontroller microprocessor will be working on low current, DC.
mm.
Then I can take this DC 5 volts and send it to the relay, and the relay will allow the AC current to be activated on to the pump.
Yeah.
Making sense. The next question is, what is the difference between series and parallel circuit? We have already discussed. Half wave rectifier, full wave rectifier, already discussed. Difference between step up and step down transformer. Step up transformer that increases the voltage when secondary winding got larger number of windings, then it will step up, and if secondary winding is low number of winding, it will step down, means lower the voltage. Let's see what it is. I Someone got calling.
From my side, no problem.
Okay, so step up transformer increases the voltage of an AC power supply, while a step down transformer decreases the voltage. Transformer work on the principle of electromagnetic induction, in which a changing magnetic field induces the voltage in a coil of wire. Okay, in a coil of wire, a coil of wire. Okay, coming to the next question. What are the basic component of electrical circuit? From the childhood we are making the electrical circuit. Let's see, let's check what I remember. A source, wires, a load, a switch. Hmm.
That's it.
Let's see what it is. The basic component of an electrical circuit are a source of power such as battery or generator, a load such as light, bulb or motor, wire to connect component, and switch to control the flow of current. I missed wire na.
No, you said wire.
Okay, wire. Okay. Now the next question is, what is transistor? What is transistor? Guys, any idea?
It have three sources. I don't know much deeper.
Hmm.
In semiconductor wise, PNP, NPN, like that they will
Hmm.
say.
Hmm.
Uh,
Hmm.
I learned so much before. I'm just recollecting. If we give a signal to any one circuit, it react in some way, and if we give a signal to some other, uh,
Forward bias, reverse bias. You are talking to. Mm, you are saying
yeah,
something
yeah,
else.
yeah,
Let's.
yeah. In these three ways, we give signals to each and everything. It reacts in different ways. That much only I know about
Transistor.
transistors.
What are the types of transistor?
So mainly it is going to be a switch, and the transistor mainly you can even mention as three legs: emitter, base, and collector.
Okay.
Emitter, base, and collector. Yeah.
So I'm not sure in NPN or PNP, it will be a switch. But
Yeah.
in one case, when we supply the voltage, it will open up the main path between the
Okay.
rest of the.
So can
Uh,
I say that a transistor is an electronic device that is made up of semiconductor that is doped with some trivalent, pentavalent element, and it has two types, that PNP transistor and PN transistor. It has three part: emitter, base, collector. Emitter emits, base not making sense, will not into get
neutral,
no,
neutral, yeah.
base is neutral,
Base is the ground.
and collector where source. Let
Hmm.
it see. A transistor is a semiconductor device that can amplify or switch electronic signals. It consists of three layers of semiconductor material with two junction between them, and can be used to amplify signal, switch on and off, and control the flow of current. So it has got three work. It can amplify the signal, it can switch on and off, and it can control the flow of current.
Wait,
Okay.
guys, can you hear me?
Yes,
Yeah, sure.
we can see
For
you.
me, just said I left. I am still in the meet.
No, no,
My phone is like,
must be using your. I thought you are also using your laptop. That's why it was
no,
showing
no,
to.
no, some issue. I don't know. Let's see.
Anyway, transistor is like a semiconductor device
Oh, shit.
that some got and PNP and P. There are something emitter base collector. We all have heard about this. Not to go into very deep. Okay, we can discuss it later. There is some SCR circuit also. We'll also discuss it later. I have some sorts of electronic question. We'll make a differentiation for that. No issues. Now coming to the next question. Okay. Next question
Hmm.
is Next question is,
What is a multimeter?
what is a multimeter? Yes, it got multi-purpose, that can also measure voltage, that can also measure current. Let's see what it is. A multimeter is a handheld device that can measure several electrical parameters such as voltage, current, and resistance. I missed resistance. Sorry for that.
And also, it can check connectivity.
It typically consists of digital or
Yep,
analog
that's an
displays.
important one.
Hmm. Yeah, it can check the connectivity by checking these three parameters, no, voltage and current. If the circuit is open, then the voltage will be zero, or current will be zero, or resistance will be maximum. What?
It's just a meter. It just show beep sound.
Uh, it has got digital display also, na?
Yeah.
It is
There are two types. You mentioned that analog will have it and separately, and
no.
digital will have
It
separate.
is not just beeping sound. It got digital and analog display, a set of probes or leads and selector switch to choose the measurement mode. Okay, so now coming to the last question of the session is
We can also mention some of them can even measure temperature sometimes. Multimeter.
that temperature measuring device is thermocouple, na?
Yeah.
Yeah. So what you do is on the side, on the bottom, we have those two places for the
Tem
needles.
temperature measuring device or thermistor.
Thermistor.
Yeah, no,
Thermocouple.
but
So both can measure, yeah. Okay.
Yeah.
but
Nah.
some multimeters have the feature to
Mm,
select the temperature as well.
mm.
Okay.
Okay. Now coming to the last question of the session is
Hmm.
what is the difference between an open circuit and closed circuit
Okay.
And short
So
circuit.
and short circuit?
yeah,
Sorry.
open circuit is the situation in which
Is the
the
question
like
is
two.
not wrong?
No. I have the difference in my notebook.
Okay. Yes. Go ahead.
Like open circuit is the situation in which the closed path of the electron is broken.
And what is the
In
short
short
circuit?
circuit,
Mm,
it is a situation in which an unwanted low resistance is created.
does not get feeling doesn't get feeling for
That
that.
So maybe we can say
like in
open
open
circuit
circuit,
basically means that
it has
the circuit has
the
no return terminal. So that means it is just an open circuit. There is no path for electrons to come back to the source which is powering the whole circuit. So no transfer of the electrons or current will take place because there is no return path.
how we can say that the resistance is infinite in the open circuit.
Yeah.
Um,
So that will be the open circuit. Short circuit, I think what we can even say is where suddenly one segment of our circuit has been cut off because of the short circuit. So the electrons will take the path of least resistance. So if suppose between item number 3, 4, 5, 6, if I've suddenly connected one wire between 3 and 6, it will bypass 4, 5 and 6 and immediately from 3 go to number 7. So I've basically cut off item number 3, 4, 5, 6, whatever in
exactly,
between.
exactly. Like the current will not go where we will want the intended path. It will go at the shortest, like a least resistance path, where it will face the least resistance path. Okay. So an open circuit is an interruption in the current flow, while a short circuit is an unintended and low resistance connection between 2 points in the circuit. Both can cause
Yeah.
problem in an electrical circuit and must be identified and repaired to ensure proper operation and circuit. Okay. So in open circuit current, in open circuit, what will happen? Some if some wire is getting cut and the circuit is getting incomplete, is the same as the open circuit, na?
Yeah.
Yeah.
For any component failure.
Component
But
failure.
at the same time, if suppose
Mm,
before the wire gets cut,
mm,
it might get a slight, damage.
Yeah.
If this damage touches the other terminals, imagine, live when
Yeah.
uh, the neutral
Like
wires
if
touch, that will be the short circuit, which can cause a spark and the fire also.
or we can say that the when the two live wires touches each other,
mm.
that might be the reason for the short circuit.
Yeah.
Okay, guys. Uh, I think it's a high longest session we had ever done, na? We have ever done, na? Till now.
Yeah, and
So
I have another two questions doubt.
yes,
New question.
let me
Have.
write it. Write it. Okay. What
Yeah.
is
Could you say what is meant by static electricity?
the electricity that is flow due to the static charge, that charge at rest? If two charge at rest, they will generate an there will be an electric field now, that is static electricity. Example of static electricity is what, yeah?
That balloon, right? When you rub a balloon or a comb with a
Hmm.
woolen cloth
Hmm.
and you keep your hand next to it, your
Yeah,
hair gets attracted.
that is static electricity. And what was the second one terminology? Opposite? Dynamic electricity.
What, brother? What electricity?
If there is static electricity, there must be something like dynamic electricity also, no? So what was the another question of yours?
Then what is mean by this straight current?
Strict current.
Yes. Yeah, STRAY.
अरे यार, I have heard this terminology, streak current, eddy current. थोड़ा
Yeah, eddy current, I know, but this straight current.
streak current I have heard, यार. Let me write it. What is streak current? Okay. Any other doubt?
No. This much only
And
because this static current is applied in rotation of crankshaft. That's why they earth and the crankshaft. If you see in
please,
marine,
bro, provide a resource, then only we can discuss. Okay.
yeah,
Before
okay.
that, if we stick with the some wrong concept, it will be very hard for us to get overcome from
Because
the
I saw this in a marine inside. That's why I'm just saying.
provide that source, na. Okay.
Okay.
What is any cross question, any further question from Rakesh and Avito that we can discuss in the next question, next session, whenever there will be.
I think for now these are enough,
Uh,
along with whatever cross questions I put in the middle.
okay. Okay.
Gyan, please just share the notes. Okay.
I have written only 40 question for the time being. After 60
What are
question, okay, I will be sharing.
One
Okay.
one more main thing that we have not covered today is three-phase induction motor. Full answer.
Three phase induction motor, full answer. But I think I haven't covered what is the generator and working principle. Three phase induction motor and full answer.
So it comes to the same thing: squirrel cage, all of that part,
Oh,
and
working principle.
asynchronous motor, all of that.
Yes, sir. That
Yeah.
just got a basic idea. I will be putting a session for
Hmm.
to discuss the deep in alternator, three phase induction motor, generator, in deep transformer. That is big component that can be asked, really
Hmm.
asked. 4 to 5 only, 4 to 5 questions. These were a certain sorts of 60 question, na. So that's why just a superficial level we discussed. We can will do that. Okay. So thank you guys. It was really nice. I
Yeah.
didn't have thought. I had thought only Avito will stop with me and maybe Rakesh if his network will give him support. But Karthik, nice to see you. Keep
Today
joining us.
I didn't have shift. That's why I'm just sitting.
Uh, no worries.
Otherwise, I would also left.
Uh,
Today I don't have shift. That's why I'm just.
no worries. No worries. Nice to see you all here again. I have last from the last time. I think from the last week I was not having a meeting, so that's why the momentum was flushed out. But I have to keep the momentum, guys. Thank you, guys. Thank you, Avito. Thank you so much. And I am just
Thank you.
Chal, good
Thank you.
stopping a recording. I have to some work with Avito. Okay, guys. Mm.
Yeah.